We are going to start shortly in maybe another 3-4 minutes. Okay, so thank you everybody for joining and making this happen even for difficult timings across the globe. You all are present. Thank you so much for that one. Okay. Our slide decks are visible, right?
Yes, please.
Oh, fine. Thank you.
Very good afternoon to all of you. I am Sudhanshu Padi, Senior Manager in NTPC Corporate Quality Assurance. And along with me, Madam Pushpanjali, Manager Engineering. Welcome all of you to this session of GATES. It is indeed a proud privilege to host and welcome you all in today's session with the theme Digitalization and Automation, including Cybersecurity for Reliability. Digitalization and automation refer to adopting digital solutions in the business process of organizations, which can result in significant changes in their business operations. Such modification can impact various aspects of an organization like user experience, business processes, target markets, customer relationship, and even diverse cultural implications. On the other hand, cybersecurity aims at protecting systems, networks, and programs from digital attacks. Therefore, to ensure reliability, organizations must embrace the technological solutions and secure themselves from cyber attacks. On this note, let us see a small clip on today's theme.
Welcome to this session on theme, digitalization and automation, including cybersecurity for reliability. Digitalization, automation, and cybersecurity are the three important ingredients for sustainable and reliable digital business ecosystem. Digitalization and new value chain constellations can lead to significant improvements in design, production, operation, maintenance, and boundary management. Thus, it becomes a stepping stone towards the journey of sustenance. Automation is the key to lower costs, improved safety, reduced lead times, and faster ROI. Understanding and mapping the enterprise risk profile over the entire cybersecurity value chain is critical in these testing times. Today's new digital world hinges on everyone willing to participate in this exercise of collective learning. This is the time to rethink, reimagine, and restructure how we recalibrate our business strategies to ensure growth and innovation while our business and the surrounding society evolve. We hope this session creates the platform to ensure true partnership across all the stakeholders to collectively provide digital opportunities for all. Thank you.
Thank you so much, sir. Thank you so much, sir. This video very well explains the subject theme of the session. To make the session vibrant with the presence, now it's time to introduce all of you to our session chair, Sri M.A.K.P. Singh. Sri M.A.K.P. Singh is member Hydro CA and the Chief Information Security Officer, Ministry of Power. He is an electrical engineer, graduate from IIT Kanpur, and has acquired MBA degree from IIT Delhi. He has 12 years experience in Regional Electricity Board, 3 years experience of managing NR Road Dispatch Center as Member Secretary NRPC, New Delhi, and WRPC, Mumbai. In CA, he had also worked in various capacities. His contributions to India is immense. It is a great honor, sir, to welcome you on this session. A big round of applause for Sri M.A.K.P. Singh, sir. Sir, we welcome you for the session to have wonderful time with lot of knowledge.
Thank you so much. Let me now introduce our session co-chair, Sri Litan Nandi. Sri Litan Nandi is the Executive Director, Information Systems and Head of Information Technology in Indian Oil. He has 35 years of experience in the field of ITES, ICT, and has contributed immensely to bring digital interventions for business transformations, including important projects of Government of India and Indian Oil such as DBTL, PMUI, eKYC, Retail Automation System, Enterprise Content Management, and Integrated Software Applications. It is a great honor to welcome you, sir, on this session. A big round of applause for Sri Litan Nandi, please.
Thank you so much. It is a privilege to introduce our esteemed presenter, Sri Amar Thale, Technical Sales Consultant, Aviva. Sri Amar Thale is a chemical engineer with 19-year plus experience in the domain of plant refeed and detailed design engineering of various sectors like oil and gas, refineries and chemical industries. He is involved in unified engineering, unified project execution, and asset information management solutions. During this period, he has worked with many EPC to support in their digital transformation journey across various industries. It's a great honor, sir, to welcome you on this session. A big round of applause, Sri Amar Thale, please.
Thank you so much. Now I introduce our esteemed presenter, Sri R. Sarangpani, sir, Chief General Manager, NTPC Limited. Sri R. Sarangpani, sir, is Head of Station Engineering Group at NTPC Raipur. He has about 34 years of experience in the power sector, both in engineering as well as in O&M areas. He was Head of Maintenance at India's first ultra supercritical station, Khargone. His focus areas are HMI engineering, cyber security, advanced process control, digital asset management. Sri R. Sarangpani was a topic leader and the only team member from India for preparation of IEC 6244.324 standard for cybersecurity of industrial automation systems. He spearheaded a project for remote operation of a hydropower station and is leading the digital transformation team and prepared a digital roadmap. It is a great honor, sir, to welcome you on this session. A big round of applause for R. Sarangpani.
Thank you so much, sirs. I now introduce our esteemed presenter, Mr. John Conway, President of universalautomation.org, who has joined us online. Mr. John Conway is President of universalautomation.org, whose mission is to drive adoption of a common automation layer based on the IEC 61499 standards. A mechanical engineer by training, Mr. John has worked for 35 plus years in the automation industry in various roles from PLC programming, project management, system sales, and merger and acquisitions. He started his career as part of Texas Instruments automation business, spent several years working for Siemens Automation and Drives before joining Schneider Electric in the late 90s. It's a great honor, sir, to welcome you on this session. A big round of applause, Mr. John Conway, please.
Thank you so much. Let me now introduce our esteemed presenter, Mr. Andrew Ginter, VP Industrial Security, Waterfall Security Solutions, Calgary, Alberta, Canada, who has joined online. Mr. Andrew leads a team of experts who work with the world's most secure industrial enterprises at Waterfall Security Solutions. Before Waterfall, he led the development of high-end industrial control system products at Hewlett-Packard, of IT/OT middleware products at Agilent Technologies, and of the world's first industrial SIEM at Industrial Defender. It is a great honor, sir, to welcome you on this session. A big round of applause for Sri M. Andrew Ginter, please.
We also welcome all the dignitaries present here offline and as well as connected online. including Kiran Kumar Vyas sir. We welcome you heartily, sir, to this session. With such experienced and knowledgeable persons among us, this session is going to be a learning session for all of us. Now, the presenters will present their case studies. After completion of all the presentations, we'll have a short interactive sessions and questions from the audience. After completion of all the presentations by the presenters, I request Mr. Kodwe and Mr. Ginter to stay connected with us throughout this session. At this moment, it is a humbly being put through to all the presenters to please stick to the time limit of 15 minutes. A buzzer will be played in 12 minutes. At this moment, I request Sri M.A. K.P. Singh sir, who is our esteemed chair of the session, enlighten us with his thought and to conduct the session. The session is all yours, sirs.
This auditorium is well. I have presented many inaugural speech here, and I am very familiar with this atmosphere, Aurobindo Hall. Today we are talking of automation. So, like when you go to a new place, you try to adapt it, and I have adopted because I have been here many times. So it is an automation process. No need to emphasize that there is a need for automation and digitalization, because what we need is to how best to utilize our existing capabilities, infrastructure, and resources so that we can minimize the cost, maximize the production, and keep the best quality output. Quality control is one of the important parameters of this digitalization and automation. But there are some aspects that need to be considered, like the anchor has emphasized on cybersecurity, and it is core to my heart. I would like to give some examples. What are the fallbacks, or what are the areas in which we have to look and ensure that we don't land into a situation where we regret automation process, or where we ourselves find in a very difficult situation to defend our proposals that we had put to our management for automation. You must have heard about fly-by-wire technology that was introduced long back actually. That was an automated process because many times the pilot used to fall asleep actually on long drive, and they needed some snap out. So that fly-by-wire technology was introduced actually, but it's now rarely used actually. Why? Just can you tell me? See, in my interview, I was asked one question actually. What is the frequency of the power generated in our flights actually? In our home, we have a 50 Hz system. In US, 60. But what is the frequency in the aeroplane? It is also a gas turbine, 110 Hz. And you know that F is equal to Pn by 120. If somebody modulates the frequency, what will be the speed of the engine? Just you can think about it. So if anybody can hack into your fly-by-wire system and modulate the frequency, they can break the engine wings actually, and the plane can crash. So it is a very risky proposition, and many of the kiddies have ventured into the playbook of the pilot's fly-by-wire system. So it is very rarely used now. Just can you think about why the automation process of chip manufacturing, they don't rely on the state electricity board or like what we talk about the grid supply. They have their own captive plants. Because when they manufacture these chips, they have a substrate, N substrate, P substrate, and that is a precisely controlled actually, very thin actually. And it is controlled by the frequency. Frequency has to be very firmly fixed at the nominal value, whatever they have maintained actually. So if it is a fabrication lab in US, they will be having 60 Hz frequency. So just think about it. Frequency is equal to 1 by T. So if they change this value of frequency, the T changes. That means the thickness of the substrate will change and the quality of the chip that you are going to get will not be as the intended one actually. So that's what we need to ensure when we are talking about automation. We have to take care of this, that these things do not happen. I was talking to Mr. Linton 90 actually, that one famous incident of Siberian pipeline burst. It busted in the remote Siberian area where people do not find it very easy to go there also. But how come a pipe burst there actually? It is a simple phenomenon. Through that pipeline itself, we are transporting the multiple types of fuels, like we are transporting naphtha, petrol, diesel, kerosene. Like suppose I am transporting right now naphtha. It is a very viscous fluid. And suppose I want to now transport petrol. It is a liquid, very light compared to the naphtha. So what I will in my SCADA, what I will change is the density, rho, the value of rho. So if anybody hackers get into a system where a pipeline is transporting naphtha and suddenly change the value of rho, what will happen is the naphtha will be trying to push at a very high velocity, and what will happen is there will be a compression in between somewhere in the line, and there that point it will be causing the burst actually, and that may be the reason why the line got burst. If it was a cyber attack, we don't know it. There are in our when we talk about power sector actually, we have an ease of comfort actually when we have a transformer. With the transformer we have all OLTC, online tap changers actually. We have online gas monitoring facilities also, like the methane gas we try to monitor actually in various parameters and ratios actually of the gases that they generate in the transformers. So we have online monitoring actually for taking decision. Suppose somebody hacks it, then what can happen? This is a big question actually. And 2 years back actually, if you remember, there was a case in USA where a transformer which was imported from China, it was intercepted actually. And this transformer was sent to Sense Lab actually. And this pushing of the transformer had a chip which had a communication port directly with the China actually. So that prompted the US president to issue an order of complete ban of the import from the China. And they had already imported so many sets of this type of transformer from China. So that's exactly what we need to ensure, that when we are automating a process, the applications that we are developing, how secure those applications are actually, whether we have tested it for the length and breadth of the parameters that may be input to this application, how the functions will be. Like one of the important testing way of is that function testing actually. We try to just give the random inputs actually, and if it functions well actually, these parameters may be beyond the normal values of what we are encountering in it actually. So if that functions well, then it is okay. The security loop analysis, that is a very support tester. So what we need today is that when we are developing an automation process actually, when we are going for a digitalization, we have to develop these types of tests on these equipments, these processes actually. And right now, our friends were talking about insider threats. What to say, the insider can be your machine itself, because one machine is accessing another machine for further processing. So if when we talk about access, we give access not only to the human being but to the machines also. So what is important is now we are talking of identity and access management actually. This is an important aspect that needs to be covered when we are talking about the benefits of the automation and digitalization. So right now I can say that suppose I don't intend a machine to be processed by another machine. So how can I prevent it? How can I identify that this process needs to be done in isolation, not through a back-to-back with the loop feedback actually. So these type of controls are very much necessary in such type of systems actually. Many of the incidents has happened, and I would like to uh, not emphasize, but you can find many instances in our own plant itself that can be replayed by any of the hackers, like tragedy of Ucha. Can that be a cyber attack? Can any hacker replay it? Yes, it can be. Can a plane be just brought to standstill while in air? Yes, it can. MH370, can that in Malaysian flight crash? Can that be a cyber attack? Yes, it can. So, what is the security mechanism that we are building along with our automation process? Today, we would like to hear people who are into this field of automation and digitalization. And these digitalizations actually requires a lot of data that needs to be processed actually. And some of the data is very much confidential, maybe our IP, maybe uh, our own developed process actually of the security mechanism. So, and if it is hacked actually, we have demonstrated that the setting of the relay can be hacked. Like I can have a, if I am having a bus bar protection actually. So you all know that in a bus bar protection, you have a local breaker backup protection actually. If any circuit breaker that doesn't open actually, like due to the pole discrepancy, like if two phases have opened, one phase not open actually, what will happen? Local breaker backup will open. So like in the similar incident that had happened at Vindhyachal, and all 11 units tripped actually, one by one actually. So that can happen exactly through any cyber attack. So like I can delay some of the pole opening of one of the phases actually, and that can lead to breaker backup. Like I can reprogram any relay on the 50th instance of this opening signal actually, that relay has not to operate, it will not operate. So these are the mechanisms which we are to ensure that they function as per our own design actually. So we have to test it. Right now, the sorry state is that we don't have what are the fat and set that needs to be exercised on the applications and the components and the products that we are buying actually. Though we make a requirement in our work order, place order, the cyber security testing has to be done, but we ourselves don't know what are the patterns set that needs to be done. So that's way in for industrial control system 62443-2-4 is an important standard. Mr. Sarangpani, I would like to request to speak about it on length actually, because that is a standard which we need to go through thoroughly, and we have to become master of it if we are to reap the benefits of industrialization and digitalization. And with this, I would request all the speakers to elaborate on these aspects also when they are touching upon their own core subjects. With this, thank you. I wish you all the best. Please interact with the speakers. And if you are not able to get answer to your question, please put in the chat box or to the organization so that you can drive maximum of this workshop, because these are the this type of workshop conferences do not happen every day actually. And the speakers who are, they are the very good masters in their own field actually. So you can after workshop also you can contact them. Feel free. That's my all for you, and I wish you all the best. Thank you.
Thank you, sir. I now request our presenter, Sri Amar Thale, sir, Technical Sales Consultant, Aviva, to present his talk.
Hello. Good afternoon, everyone. I would like to first thank Gates NTPC to invite Aviva present this seminar with me. Yes, I am starting my presentation. So digitalization is a vast subject, so I will just try to cover it in 20 minutes. So the title is Industrial Digital Transformation. Okay, so these are the agenda points of presentation. So we start with the definition, then different scenario of the plan, project, industry challenges, installation vision of the industry, then till now what was the industry and what's their mission, then integrated design, change management, gateways, digital twin, some use cases. So we'll start with the definition. So what do we mean by digitalization? So the digitalization we divided into the four parts. So started with digitization, conversion of any data to the digital form. We call it digitization. Okay. So the approach is from document to the data. So moreover, we can say it is a tax entry rather than it is a document or drawing center. So so digitalization. So we have a digitized data, but we have to take it to the higher value of it. So we called it as a digitalization. Okay. So with the help of these two, we are going far away one step. So that is digital transformation. Okay. So but the digital transformation is not coming from any lower level. It has to the motto to be decided on a top level, or we can say at the enterprise level. Okay. So that somebody has to decide on an enterprise level that I need to digitalize my complete plant or complete system. So so this is basically the definitions of digitalization. Okay. So if we consider this any plant or any company moving, so they are constantly growing. So they are like a fleet. Okay, so in a fleet we have a three scenario. So scenario one is a greenfield project. So we are talking about the fleet. So we have a three scenario. One is a greenfield project, another one is a brownfield project, and third one is the already your any plant is running. Okay. And if you correlate all these plants, all these fleet with respect to the design, procurement, construction, commissioning, training, operation, and maintenance. Okay. So here we are just discussing about the scenario two and three, the challenges. Whereas if you are going for scenario one and it is a greenfield project, so we can implement all these digitalization skills to that particular project. So what are the challenges for these industries? So we have a data silos. So data silos. So different disciplines having the data in the form of hard copies or soft copies is having, but those are not intelligent ones. So we cannot reuse or produce the data from that. Then the second one is the project. So this second example is for project. So project which is going to execute. Okay, or the project which is going on a field to be executed. Okay, so the real-time project monitoring data we don't have. Okay, so let's say we have a EPC as a EPC client, they have 3-4 projects going simultaneously, and at a higher level we have to take the monitoring of that project. So we don't have data at centralized or one at single platform. So as far as the operation is concerned, so the no integration with the SAP or ERP, so that could be the one challenge. And data management system. So for the old plants, we don't have any DMS system. So now we have DMS systems where the all data are categorized in a well manner. Okay. So the fifth one is reporting dashboards and analytics. So this is kind of enterprise levels visibility. Like CEO or anybody top management has to check out how many projects are going on, what is the status of operation. So these are some challenges. So why these are the challenges? Because we don't have data at a centralized. place or at a single platform. So let's say we talk about document or drawing centric to the tag centric. So if I click on one button and let's say particular this vessel 101 is there. So when I click on this particular tag and I need to retrieve the data, so on a single click, I am getting all this data. So this is what the vision of any industry. Okay, so let us say we have this particular equipment. So we have all kind of data. Let us say this is a old plant, so we have laser scan data, TMS data, data sheets, 3D data, 2D data, whatever the data, 1D, 2D, 3D, all we will having on a single view. And this data will then, so this is one system, we will show it at an enterprise level. So as of now, you can see on left hand side. So this is the status of current industry. Old plants having PDF copy or Excel copy or vendor drawings. So it is scatter form. Okay. So now and our goal is on right hand side. So so we have seen this scenario for particular scenario 2 and 3, which are brownfield project or already plants are existing, which are running. So for that, so left hand side we have this situation and right hand side we have both. So it has to go through 3 steps. So there we have all the data, documents. Okay. So all these data and documents may be form of we are scanning the data or we are doing our 3D scanning at site, particular different site and then getting together the data. But only scanning will not suffice our purpose. We want a data, the type of data that we can play with or we can utilize those data to later in any pages like operation or maintenance, or if I want to build a new plant or I want to do some another unit, so I can use those capacities. So that it will be all be intelligent. So you can say this is the step number 1, this is the step number 2, and this is the step. Okay. So now we are just looking at step number 1. So we are going with the scanning. So now the technologies are there. No matter if your plant is 30 or 40 years old, still you can have the intelligent data of those plants. So how it is just this video which show you. So firstly, we are just locating where the scanner to be placed. Then actually the people will go there and they scan the data. Okay, so this data will be scanned and you will get the panorama view of this particular your site. Okay, so with the help of all this data, we can actually do the remodeling. There are many softwares in the industry like 3D, PDMS. Okay, so those will give the intelligent data. So now many things are like one is the 3D data, so which will get it from scanning process, and that data can be converted to the 2D data. That is one process, but already you have some PNIDs in PDF or AutoCAD form. So those data we can bring into the intelligent platform. Okay. So we called it as building. So whatever the data you have, so we as built it. Okay. So left hand side, you can start from 1D data, any data sheet could be there, or 3D data or PNID data. Okay. So and this data may be from across the disciplines, civil, instrumentation, electrical, mechanical, whatever. So once we have all these data intelligent, so we have now the technology and systems we can have at one place. And then once we have digitalized all this data, so we can monitor it through better change management. Let's say we have changed something in one system. Let's say we have changed something in PNID. So it will give notification to the downstream discipline like mechanical or piping that this data has been changed. Okay, so this way we can monitor or control it better. Okay, so the systems are like nowadays in industry. So now what we are doing with this data? So now we have come up with the digital transformation. So now we have structured data like data sheet, EMS, unstructured data in the form of Word or PDF or any other form. Okay. Then diagram, we have a 2D data, which will be basically CAD type of data, PNIDs or isometrics. And then 3D data we have. All these 3D data may be intelligent model, which we will get from any engineering companies. Okay, and this, if we have a scenario 2 or scenario, sorry, if we have scenario 3, we have laser scan data. So now what we are doing with this data? So now integrating all this data into one place. Okay, so we have different gateways. So with the help of these all gateways and standard information standard manager. So with the help of this, we can extract all this data, then validate this data and organize it properly. Okay, so that we can help this with the help of this data, we can do downstream processing. Like I want to schedule some maintenance, so I can take out the report all 600 pumps from my plant and check out all the dates. When the last we have done this maintenance of this project. So here we are collaborating engineering data with the operation data. So we called it as an asset information system, and it can be visualized nowadays through mobile app also. So now we are going towards the digital twin. So what we have on right hand side, we have the physical asset, exactly what we have in the plant. Now we are making the exact replica of it. Let's say we have some particular equipment, and the same you will get on your machine. And you can visualize it. You have to do some modification. You can just measure the distances from there and make some study of this feasibility study, whether if I put some additional pump here to this existing pump, so whether there is a place or not, or the piping can be routed. So with the on a single screen, we can do this particular thing. So you can see over here, and these all things are supported with the standard management systems. Okay, so if you can say here a plant structure and unstructured data, FT format, spreadsheet, 3D model, laser scan, document drawing, and then plant real data. So now we have just up till now we have just seen up to the design phase. Okay, design, document, construction. Okay. But when it comes to the real time, so now any pump is running. So now the technologies are there. We are installing sensors on a plant at each and every pump, and then we are getting the real-time data in the form of their pump efficiency or their performance management system. Okay, so we can have a real-time data, and based on real-time data, getting this data on daily basis. So down the line after the 6 months, I will have the historical data of this particular pump. Okay, so then what we are doing with this particular uh, data which we have taken from last 6 months. So I can correlate this data with anything happens with my pump. Let's say my pump now PLC will get us the data when the pump is already been damaged. Okay, but now we can predict it. So down the line, 15 days before we can predict it. Let's say from last 6 months, the performance curve was going well, but something suddenly happened with this particular pump and casing will going to damage. So something will happen. So it will give the data. Okay, something is wrong with this pump. So with this data, we can predict. So this is we call it a predictive analytics. Okay, so this real-time data we are getting here. So that is why we have put this red color ki plant real-time data. Okay, and then it is a maintenance data, inspection data, simulation data, and other kind of data. So now here we are collaborating design data with the operation data, and which we will help in maintenance. So we called it as asset information management. And it is so nowadays it has been we have many codes plant which is we are designing or any system is there. So it has been supported with some codes. So now we have some codes like ISO 15926 or ISO 14. So this data can be organized or validated in well manners. Okay, so what does it is having? So it may be classes, attribute, unit of measurement, taxonomy, industry standard, naming rules, life cycle based definition, maturity model, and validation rules. So now we have these different systems. So we can collaborate all these systems. This is not only for the plant. Even though you CCTV data also we can put it over there. So enterprise levels, we can have this unified operation systems where you can collaborate all your system. So this is basically called a system of system. So at enterprise level, we can see all these systems, what is their status. So you can just have this of this video. So these are the enterprise levels. One of the midstream projects video. So we can see it is a corporate view overall. Then if you come to the refining overview, you can just have a different sections: sustainability, performance, efficiency, and maintenance. So now, if you are going to one particular site or site-wise data you want, you can have all this data at your screen. So these are some curves from predictive asset management. So we called it as a data centric. So let's say we have some pump in a plant. So we can just check out where is pump is located. Can we can have all the information related to that pump. So it will give you the incident summary also. When the last time the pump was failed. So now we come to the case study. So these technologies have been adopted by many companies across the world. So we have taken here the example of Down the Realty Corporation. So they have the same challenges and they have the same goals. So now the result was ensuring information integrity and first version control as a design process, handling interface engineering between across the disciplines, civil engineering, the collaboration of all information from different sources, systems, and other third parties to improve the project relationship operation control. They will capture and recording the historical information on failures and leakage for risk assessment. These are some global clients who have benefited with these technologies. So with this, I would like to thank everyone for listening to this presentation.
Thank you so much, sir, for such an insightful presentation. I now request our next presenter, Sri R. Sarangpani, to present his topic, Digital Initiatives in NTPC.
Good afternoon to all. Respected member Hydro CEA, Shri MKP Singh and Shri Nandi, our ex-ED Engineering, Shri Vinay Kumarji, Sanarji, my friend PK Singh, Madam Saroj, and many other colleagues. This topic which I am going to present is digital initiatives in NTPC. Now this topic is very big. It requires actually in half a day session. So each digital initiative can take 15 minutes, but still I'll try to give a total overview of the various work under this measure which is taking place in NTPC, sort of a bird's eye view. A digital committee was formed in which myself and Mr. Srinivas from OS and Madam Anuradha were here, and Mr. Bodhraj, who is now superintendent, we were there. Then we co-opted various members from different departments, and we made a digital roadmap for NTPC, which was presented in ECM, and now it is under execution. Digital transformation, if you see the basic underlying reason for digital transformation. Many of the organizational business imperatives are there on the left. Safety, timely delivery of projects, reliability, efficiency, profitability, regulatory compliance, sustainability, as we are talking, gets, and customer value. And there are various problem statements. How can I make my plant more safe? How can I optimize my operation? How can I reduce my FO? How can I make my units more flexible? Already we have an expert in flexibilization, the Kesena. How can I increase my efficiency without any hardware investment? No modification in my plant. How can I do purely by software? These are the problem statements which a digital roadmap of a company will address. And these are focus of the focus areas of digital transformation: analytics, integration and visualization, advanced controls, IoT sensors, smart sensors, digital worker, and predictive technologies. These are the underlying, areas of digital transformation. NTPC has adopted digital transformation quite ahead compared to its peers. In 80s, we adopted digital controls. In 2008, we adopted SAP. Then probably we were the first company in India to adopt a M&D center, full-fledged M&D center, which was there in Noida, and now it's at Raipur, called Antariksh. Then we were among the first PSU to adopt the Pradeep paperless office. Then a remote operation of hydro project, coal dam project, was done in 2018. And it was a landmark project in the sense that 400 kilometers away, the entire operation was done from the scope complex. Then the first power station to implement AI-based performance optimization at Simadri, and the first PSU to adapt smart township. So these are the series of firsts which NTPC in the digital space had undertaken. Then this is a very big slide. It shows the as-is state of digitalization in NTPC. The green ones are the ones which have already been implemented. There are various stages, like one is in under pilot, one is under tendering, and some things are new requirements where need to be further plan and go ahead. And this is being done by multifunction teams in NTPC. Each digital initiative, there's a process owner, and he has co-opted many other people from related disciplines, and this is how we are undertaking the digitalization journey in NTPC. So I'll just take 1 minute. You can go through this. Some of them are very early, these things like Dreams, which was then about 20 years back in NTPC. Probably the first engineering organization to adopt total digitalization in drawing review management. And knowledge management, many of them were also discussed yesterday also. I'll go further. And these are the foundation layer components. One is the Pradeep, one is Office 365, which is there with the AD system. One is our process historian where all the DCS data is collected, the PI. Then we have, like my earlier presenter has presented, a universal dashboard or a single data lake. We also have an enterprise-wide data lake which is being executed, and corporate OS is the process owner for that. Then RPA platform also we have done. The commercial billing is done by using the RPA platform. And these are some of the underlying platforms on which various applications will be developed. So what is important is that as the business changes, the requirement of digitalization in each business will grow. So this is a continuous process. But once we have a platform built for applications, then that gives the foundation layer so that we can make any applications the way we want. Now, this is the roadmap where in the ECM it was presented that one is the March 24 bucket on the left side, and one is the March 25 bucket. March 24 bucket, there are various digital initiatives you can see, and as I told that various process owners are there in corporate OS and station engineering, and some in IT also, which they are taking forward these kind of digital initiatives. The hashtag mobile app is by station engineering. The APR is by corporate OS. Then advanced analytics is also by corporate OS. RFD-based stores is by IT. Real-time damage modeling is also spearheaded by station engineering with a multifunction team. And VR-based training is done by our PMI. So an auto build schedule is done by again multifunctional team, which project engineering C&I being a process owner. Similarly, we have another bucket for March 25, and that also these are some of the initiatives. I will go into digital initiatives in more detail. One is the use of AI at Simadri, where the efficiency of the unit has been increased by AI-based optimizer using changing the bias of fuel air dampers or auxiliary air dampers, and also burner tilt and auto set point. And through that process, the efficiency of the unit has improved. And also there are other modules in that where the temperature restrictions will also come down. So this solution is piloted at Unit 4 of Simadri. And Unit 3 also it has been done. And this is a system where the efficiency increase are accrued only through digitalization. No change in the process. Next is the asset management system. My earlier presenter had told about asset information system, but we are talking here of asset management system, where this was a system which was piloted at Khadgor, where the entire field inspection is done by a mobile app or using tab only. And we go into the asset and we just click the QR code and we get a checklist, which actually is the LMI on the mobile itself. And through various buttons, we are actually giving the field inspection results. And immediately after submit, it goes to the server, SQL server. So which means the field inspection data of all the assets is also a part of the asset database, apart from the real-time data. So we have a combination of real-time data and local data, the field data, as part of the asset database. Of course, the real-time data is in very high frequency than the local data. But the having the same synchronization, we can know at what time what was the value of the local data at that time. So this helps in two ways. One is that the compliance of the SOP and the LMI is automatically ensured, because unless the person goes to the QR code and enters the field results, it is not fine. I mean, it's not final. So it ensures the compliance. Second thing is that it helps the diagnostics and analytics to use the field data also as part of it. So that helps the diagnostics make more robust. This is some of the examples of the digital operator rounds. This was totally designed by me and through a team of maintenance engineers at site and IT, site IT and MTP. Next is the concept of asset health index, where asset score of a single score of an asset using multidimensional data analysis is being done. So once you have to see only the asset score at a time, if that is deteriorating, then only it calls for a deep drill down. So this is a very important concept and which is there in all asset management systems. Next, a machine learning algorithm for early warning, early direction before it reaches the failure stage, using pattern matching and a combination of an algorithm for similarity-based modeling. This was done at Khadgor, where the PA fan bearing temperature early at 60 degrees itself, it was predicting that there is some issue. So this is a benchmark with the commercial software. The right side is the in-house software. The left side is a commercial software, which NTPC had got a single user license. And when it was compared, then it was shown that same time as a commercial software does, the alert and anomaly is being displayed. So this was also done using Python, AI Python module. Then there's a concept of asset fault signatures, which is basically an FRE concept that is basically on the diagnostics. So like any medical, disease has got a symptom. Similarly, any failure will have always some symptom in the data preceding that. So if you are able to catch the pattern of data before the failure, we are able to know that a failure is impending and some action has to be taken. This was the concept of asset fault signatures. This basically is a template which was created, general template, that any asset you want to create a asset fault signature, you use multiple combinations of Boolean combinations, and or etc. And also the rate of rise of any parameter. And then you can create asset fault signatures yourself. Now, this is the asset management system which we are making, where station engineering is the process owner and the various departments. We are OS site as well as IT is part of it, and where the different components are being done. One is that digital operator rounds, as I mentioned. This is we have remade it actually in Power app, because that is the Office 365 module which we have got, and there's a concept of no code, low code which comes that anybody without coding also can create the apps. Next is the machine learning model, as I told, which is here. Then the IoT data, where the vibration sensors can be put on the database through IoT, direct signals, actually, where the FFT analysis, etc., is also can be done as a part of the sensor itself nowadays. Next, the asset health index I've already covered. Next, the asset fault signature. There are three ways of creating it. One is the human experience, and one is the OEM or the bodies like EFRI, where EFRI also has got asset fault signature. Other is the through deep learning. The deep learning framework is that you give the faults, how many times it has occurred actually, and you give the data preceding the fault. The system automatically learns and gives you the pattern of the fault signal. So that these three ways are there, and this is basically a knowledge management to capture the tacit knowledge of the O&M person in the as an institutional knowledge management system, where this can be created. The other option of creating the asset fault signature is doing a FMEA as part of the RCM. RCM has got FMEA and FMECA. They, through do proper analysis of the failure history of the past 5 years, we can actually derive the asset fault signature. So this is the total system which is being made. And through this system, the entire maintenance, the structure will be changed at site. Thank you very much. So this is my presentation. I could not, go into individual detail because it's a very big topic. But as Sir has requested me, so I will just use 2 minutes to tell about the IEC 62443 2-4 standard. I was privileged to be a part of this standard. I was the only member of India. This standard basically talks about the industrial control system, the security aspect of it. And there are various topics, like I was a member of 3 areas of the standard. One is the patch management, one is the account management, and the other is the remote access. So there are various areas of patch management, like whatever patches come from the Microsoft or the OS, that has to be qualified by the DCS vendor. So all types of requirements are placed actually, and each requirement is classified into gold, silver, and platinum. So platinum is a basically basic requirement which has to be met by all vendors if they want to qualify and certify. The other requirement are silver and gold. So that was a basically concept of security for fit for purpose actually. But as such, we had a brief discussion with Singh Saab also that security cannot have a fit for purpose. It has to be ensured. I mean, there's no go. There's nothing called a no go. It has to be done. So that type of, but then the requirement that the standard was made by Shell, and Shell has made a standard that time which was called WIP, sorry. And based on that WIP standard only, that draft was used for the 62443. Now it has become a de facto standard for all industrial systems. And if you follow that standard in toto, in fact, you will not get any security breach, because that standard is a very, very detailed standard. And I had my job was that as a topic leader to collect whatever national committees the comments were given to resolve that whether I should take it the standard as it is or with modification or reject it. So we have to give answers to the total committee that what job we have done. Through this process was a very big learning actually, because many of the things like, I mean, there's a presentation to waterfall also. These terms and all we could get only after this exercise of resolving the comments. So sorry, I've overstepped my time, but thank you. Yeah. Yes.
Generally, what happens is that we store the data actually, figures, and we compare and try to find out the damages that is happening for taking a call for maintenance actually. So how do you compare the images of the previous inspection or and the present inspection so that you take a call for the maintenance?
Yes.
So kindly explain the how images are compared.
Yes. So right now the facility what we have kept is only like in a bank last 10 transaction. See, we are able to see that facility only we have kept actually. That I can see the inspection record of the last in any transaction, but the last 10 transactions are kept as a ready reference. If I want to see the inspection of 4 days back, I can see the inspection results and also see the images and also the sound. Because from the mobile, you can take a sound of the machine and store it. So suppose I want to see the sound of one week before and the current sound which is already in my ears, I'm already at that equipment. Then I can compare whether the sound is deteriorating or still remaining. If it is deteriorating, then definitely there's a cause for more concern. So that type of references we are doing. But you can still go further for image analytics and other things that we have yet not yet incorporated. We plan to incorporate later, not yet actually.
Change detection and the anomaly detection. So change detection, it will say it was like this and today it is like that. And it can also, I mean, if you have given enough projections and the AI is trained, it can also tell, probably by next month and, it's going to fail. I mean, yeah, this is going to the condition. So I think it's all possible now, thanks to the AI technology, which has advanced.
Very right, but we are going very step by step.
Yeah.
First, the acceptance of the field inspection by the local operator. That is the first challenge.
Yeah.
They have to do it. In fact, in Khargone, when this was piloted, 1 month everybody did it. But after that, because the management trust if it is not there, then it slowly they will figure it. So
Actually,
what is important is first you have to go step by step.
Actually, it has to be made the need,
Yes.
I mean, without that, they cannot do.
Yes.
So once it becomes the needs, then it will automatically be in the system.
Very rightly told.
Sir, just please, can you hold the questions till the end of the session, please?
Yeah.
Because the other presenters are waiting. Okay. Humble request.
Thank you so much, sir, for such a nice presentation. I now request Mr. John Conway, President of universalautomation.org, who has joined us online and will present on the topic sustainable energy transition through universal automation. Mr. Conway, if you can, if you would like to share your presentation and give presentation from there.
Yes, can you hear me?
Yes, sir, you are audible, sir.
And can you see my screen?
Yes, sir, it is visible, sir.
Yes, hello everybody. First of all, thank you very much for inviting me here today to talk at this conference. I appreciate this invitation. I'd also like to thank Mr. Kiran Kumar Vyas, who helped me prepare this presentation. Okay, the topic of the presentation today, I'll talk about automation. Okay, in the automation as an enabler, a very important enabler for this energy transition, for sustainable energy transition. and also the digital transformation in more general terms, okay? So, I mean, the whole world, we're all moving to this, to a greener future, getting rid of our dependence on fossil fuels and moving to more greener renewable fuels, okay? I think one of the issues we have here, though, is we are not moving fast enough. And so we need to accelerate, okay? Now, it's a very complex problem, but an important topic here are the automation systems that are behind all these new greener energy type systems. And automations and systems themselves, if you want to support this transition and support the acceleration, fundamentally, there has to be a change and we have to move more quickly, okay? We have to make a fundamental change to the way we do automation. Now, if we take a closer look at some of the topics, and this is a general theme, but if we look at carbon capture, for example, okay? Carbon capture, if you analyze what is required, generally you'll see that we need to move faster. We need to lower the costs, and we need to reduce the energy consumption of the solutions. Okay, and if you then take this back and analyze this and bring it back to automation, essentially we need to have much more modular processes, so we can essentially build modular plants and scale production by just adding modules. Okay. And this is quite easy from a mechanical and electrical point of view, but it becomes much more complex when we start talking about automation and automation software, which is technology that was not designed with modularity in mind, okay? More modular allows us to scale more quickly. We need to have, it would be great if the equipment could be supplied with the automation already embedded, okay? So that we could just plug in equipment when it arrives on site and have the equipment function correctly, and actually self-discover the rest of the equipment and run, okay? And of course, this raises intellectual property issues because the process OEMs and the process licensors need to be able to embed their software and protect their IP, okay? Now, if we look at green hydrogen, we see some similar challenges. Okay, overall cost reduction, it's still too expensive there. We've got to reduce the cost. And part of the reduction of cost is being more efficient in the way we engineer and build the plants, yeah? But we also have to be able to, again, scale, okay? Add additional electrolyzers in a very quick and efficient manner to increase production of hydrogen as the requirements grow, okay? And this requires greater flexibility. And part of this, if you analyze these problems and fundamentally look at what's required behind it, we're moving more and more to a need for more flexible software and a greater investment in software by the final end user. On the previous presentation, which was very interesting, from Mr. Sangapani, and I apologize for my pronunciation of his name, but he mentioned multiple topics, and a lot of the topics were linked to software, you know, advanced control, model-based control, analytics, predictive maintenance. It's all about software, and we must remember that a lot of the information starts out in an automation system somewhere, a PLC or DCS system. Now, one of the issues we have is today's automation systems, they are closed proprietary systems. They're very good at real-time control. They're not very good at interfacing with other applications that was mentioned in the previous application to do these more complex use cases, okay? So we must modernize automation. We must make it easier to connect automation to other applications in the enterprise, predictive analytics, artificial intelligence. When a drone flies by, why can't the drone connect to the PLC and get data automatically from the PLC? That should be possible, and it is possible. And we have examples of that already working today. So make it easy to connect to other systems, and then the automation itself, the application software, because we're investing more and more money in application software, for example, the model-based controlled applications that we saw previously. If I have to rewrite software every time I change from a Siemens PLC to a Schneider PLC to a Rockwell PLC, then why do I have to rewrite the software? The software should be hardware independent, okay? So software should be hardware independent. It should be built in a modern way using modern techniques so I can create libraries of software components and reuse them in a very robust manner. What the IT software world calls object orientation. That's just a an expression of being able to create libraries of software components and reuse them easily. We should learn from the IT world. You know, we have Linux, we have Android, we share technology. Why don't we share technology in the automation world? And we have a challenge, I think this was mentioned by one of the speakers, of attracting younger engineers into our business. So what is universalautomation.org? It's really three things. Number one, it's a technology based on an IEC standard. So all this modernization techniques I talked about, object orientation, event and data-driven architectures, software components, hardware-software decoupling, so the application is independent of the hardware. That's been defined in an IEC standard, the IEC 64099 standard. So that's the good news, okay? We don't have to invent this, it exists. Now, the standard itself is good, but that's not enough. Let's do what the IT world does. So Universal Automation actually manages an implementation of the standard. So members of Universal Automation have access to the shared source code that implements this standard, and they can download the shared source code and implement it on an automation platform to create a universal automation offer. Okay, and the third component of universalautomation.org, it's a non-profit association with members from the user community and the vendor community. Okay, so we have users like Exxon, Shell, Cargill, Nestle, who are using this technology, and then we have companies from the vendor community like Schneider Electric, like Yokogawa, like Phoenix Contact, like Omron, a recent member, who will take this universal automation runtime and create this offer of universal automation offers, a common automation layer that's modern, object-oriented, and allows us to build applications, what I call plug and produce programming, using libraries of hardware-independent software components. Okay. Now, we set this up 2 years ago now, and the organization is growing rapidly. We have today 66 members from the vendor and user community. Here I'm showing some of the members as they exist today. This is not the complete list, but you'll see some of the more well-known names. On the vendor side, you see companies like Yokogawa, Stahl, Schneider Electric, Phoenix Contact, Omron, that actually make traditional control either PLCs or DCS systems. You have other companies that, for example, Cognex make vision systems, very, very popular vision systems using artificial intelligence to analyze and do quality control using vision. We have companies like Belden that build network infrastructure for automation networks. We have companies like ASRock and Advantech that build industrial edge compute devices. And these companies are in the process of putting the universal automation runtime on their products to release a universal automation compliant offer. And of course, we have the big end users like Cargill, ExxonMobil, Shell, Veolia, Nestle is a member that basically join the initiative, to sponsor the initiative, and to encourage their vendors to join and release an automation offer with this common, modernized, shared universal automation layer. Okay, so growing very rapidly. Offers are available on the market. Schneider Electric was one of the founding members of universalautomation.org, and they released their EcoStruxure Automation Expert offer 2 years ago now. So this is not PowerPoint in theory. These offers exist, and we now have 6+ offers that are available on the market from companies like Stahl, Kongsberg, Phoenix Contact, Belden, and by the end of the year, we'll have more than 10 offers on the market using this common automation layer that allows you to build applications by plugging together these hardware independent software components to create applications. Okay. Now, to finish my presentation, a couple of examples of that are relevant to this seminar. This is an example from the United Kingdom, a UK company called Brilliant Planet, and they build carbon capture systems In fact, what they do is they grow algae inside these large basins, and the algae captures the carbon dioxide in the atmosphere. Okay, so they build these. They're building these plants right now in North Africa to actually capture carbon. The plants themselves, these ponds, there's an optimum size for the pond. If the pond is too small or the pond is too big, it doesn't work so well. So there's an optimum size for these ponds with the algae inside. And their main interest in this new modern universal automation technology was the modularity of it. So they could build the control software to be modular. And when they build additional ponds, they can add additional, the control software itself is modular. There's no additional programming that has to be done. They simply add the new module to the system, and the control system automatically functions in a plug and produce manner. Okay. Of course, they use Schneider Electric hardware, but of course they have an option. They can use different hardware platforms depending on where they're building the plants, who their customer is, etc., etc. So basically, modern object-oriented modular automation software that is a key enabler of these carbon capture algae farms. Okay. Another example I'd like to mention is this is a green hydrogen project by a company called Velo, who basically, again, use this technology for a couple of reasons. One, again, modular design, because the hydrogen plant itself, it's made up of a lot of electrolysis modules that you add basically to increase capacity. So again, the software itself is modular and can be increased by just adding the mechanical, electrical modules and the control module as well, without having to reprogram all the software. Of course, this requires also a lot of monitoring, tracking and tracing. And so there's integration with what I call the enterprise software applications to do analytics, predictive analytics, digital twin, and these sort of thing. And again, this modern universal automation technology allows you to easily connect and integrate a real-time control application with some other application, whether it's analytics, artificial intelligence, or whatever, okay? So I end my presentation here to respect the time. There's more information available on this topic. You can contact me yourself, John Conway, if you'd like to know more. Visit our website, universalautomation.org. You can see which offers are available. You can get an up-to-date view on the different members, and you can also contact us through the website. We are driving very hard to recruit more members from the user community, from the vendor community, to really drive this new technology, to have a common automation layer, which will really help us accelerate the implementation of the digital transformation in general, and more specifically, the new energy systems that we need in the future to move to a greener, more sustainable future. So I'll thank you very much. I will pause there and take questions now or later on in this seminar.
Thank you, Mr. Conway. The questions we'll have at the end of all the sessions. Our next presenter is Mr. Andrew Ginter. May I request sir to come on podium, please? Sorry, he's joining us online, so we may have his presentation now.
Thank you. I'll bring up my presentation here. Give me just a moment. So thank you for that, and thank you everyone for joining and the opportunity to chat with you. I'm going to be talking about use cases for unidirectional communications in the electric sector. Now, these use cases are, the examples I have are in the electric sector. This class of technology is used routinely in oil and gas, in rail systems and metros, in water treatment plants, and other manufacturing, heavy industry, and critical infrastructure applications. But I'm going to focus on the electric sector. Before I dive into the use cases, though, let me give you just a bit of background on the cyber security threat environment. This is from Waterfall's report for 2023. It's on the Waterfall website. You can see the URL. The report looks at all cyber attacks in the public record since 2010. Cyber attacks that caused physical shutdowns or equipment damage in manufacturing, heavy industry, and critical infrastructures. Using those criteria, in the year 2010, there was one attack that met those criteria. That was Stuxnet. In 2011, there was 0. In 2012, there was 2. This went on for the whole decade. For the whole last decade, 2010 through 2019, there were between 0 and 5 attacks per year that met this criteria. It was a theoretical problem. Since the turn of the decade, in 2020, there was 18 attacks. There were 23 the following year. Last year, there were 57. And we're projecting even more this year. We've gone from a theoretical problem to a very real problem. And what we observe is that a large fraction, the majority of these attacks, where we can identify a threat actor, the majority of these attacks are ransomware. And we observe that some ransomware groups are using nation-state attack tools and techniques. Some ransomware groups are actually backed by nation states. North Korea backs ransomware groups in order to secure foreign currency for the sanctioned regime. So this is the new reality of network attacks. What we have is nation states coming after each other, nation states coming after, attacking critical infrastructure. I'm in Denmark today. Just 2 days ago, there was a report came out that Russian threat actors had compromised 22 critical infrastructures in Denmark and been thrown out again a few days later. But there was a detailed report. So nation states come after critical infrastructures, and ransomware groups with nation-state attack capabilities come after everybody with money. This is the new reality. And so it's not surprising that just a couple of years ago, the government of India, the Central Electric Authority, put out their cybersecurity in the power sector guidelines for 2021. And one of the requirements is hard isolation for critical infrastructures from internet-facing networks, networks that have internet connectivity. So to that, with that background, hard isolation, what does that mean? Well, a very common way of achieving hard isolation, I mean, the easy way to achieve hard isolation is an air gap. The problem with an air gap is that none of the air gap impairs all of the digitalization initiatives that we've been talking about in this session for the last hour. Data in motion is the lifeblood of modern automation. If we want predictive maintenance, if we want, operational equipment effectiveness, if we want to use outsourced, managed security service providers, if we want any of this modern automation, the data has to move. So here's a tool that lets the data move without risk, that preserves the hard isolation requirement. The tool goes by different names. I call it unidirectional communications. More specifically, there are products out there called unidirectional gateways. There are products out there called data diodes. Very quickly, how does it all fit? The NIST 882 standard defines it the most clearly. NIST defines a unidirectional gateway as a combination of hardware and software. The hardware is physically able to move information in only one direction. There's a fiber optic transmitter, a laser in one circuit board under the hood here. There is a fiber optic receiver on the right under the hood. you can, there's a short cable connecting these two devices. You can send from the industrial network, from an OT network into a corporate network, and there is physically no way to send anything back through this device. There is no laser on the receiving circuit board. So the hardware is one way only. And this is in fact how NIST, the NIST 882 standard, defines the term data diode. Sometimes you hear that term applied. Data diode is the one-way hardware. NIST defines the unidirectional gateway as the one-way hardware plus software, and the software makes copies of servers. What does that mean? Well, imagine there's an OPC server in a DMZ in the industrial network that is sending data into SAP or into the cloud for these modern digitalization initiatives. The unidirectional gateway software logs into the source, the OPC server on the left. It asks the server for all of its tags and all of its values. Typically, it's configurable, but that's the typical configuration. Gets that snapshot of 10, 20, or 50 megabytes of data, pushes the data through the strange one-way data diode hardware, and on the other side, the software populates an identical server. If it's OPC on the inside, it's OPC on the outside. Puts the data into that server. If it's Pi on the inside, it's Pi on the outside. And now anybody on the outside network, on the enterprise network who needs the data, asks the copy of the server for the data and gets the same answer as if they'd asked the live system. But of course, the one-way hardware means nothing can ask the live system. But in a sense, nothing needs to ask the live system anymore because the unidirectional software has made a copy of all of the data that's allowed to be shared with the enterprise or with the cloud. And so all of the data is out here already. There's no need to communicate with the industrial network and put that network at risk. So here are the use cases. I've submitted a paper that will be available in the conference materials. In the use cases, I identify what class of solution, unidirectional solution, be it a unidirectional gateway or a data diode, can accomplish these use cases. I look at the four sort of verticals, the large strokes verticals in the electric sector: power generation, power transmission, power distribution, and the balancing, or some people call it a transmission system operator, the function that balances load against generation capacity second by second. And so in these use cases, we need to send data out for general business use. We call it safe IT/OT integration. The unidirectional gateway, the software makes copies of historians or OPC servers or relational databases. This is used across the board. The next one down, an outsourced security operations center. We need to send Windows logs. We need to send syslog. We need to send SNMP traps and even some, security configuration files for, firewalls for devices out into that operations center so that the SEM, so that the security analysts can, figure out how we're doing security-wise. This, again, is used across the board. And this is something that unidirectional gateways do. They make copies of these things. Vendor remote support. This is very important for power generation because the turbine vendors need to come in and help us support these, $300 million assets. You might imagine it's impossible through a unidirectional gateway. In fact, it's not. What's used most often, but there are variations, is the remote screen view. You have the turbine vibration workstation. An engineer sits down at the workstation, turns on remote screen view, and the vendor logs into a website and can see a picture of the screen. The vendor, of course, cannot touch anything through the one-way hardware, but the vendor can be on the phone giving advice, saying, okay, please bring up the vibration diagnostics. And the engineer moves the mouse. And the vendor can see the mouse moving and say, no, that's system diagnostics. 2 further down, that's vibration diagnostics. And they work together to provide support to the turbine through the unidirectional communications. All of these use cases support the hard isolation requirement. Here's a more complicated one, balancing authorities, dispatch. This is the energy management system that balances power generated against load second by second. The protocols that are used for this coordination tend to be ICCP or 6850-5-104 or the 61850 MMS. All of these protocols, the unidirectional gateway software is able to basically copy the protocol server out, emulate the protocol server. And so what we see is a unidirectional gateway oriented out to, from a balancing authority, from an energy management system, copying the data, the set points for that energy management system out to a wide area network connection to typically 1 or 2 or 3 dozen partners, because the balancing authority must send new set points out for the generators and emergency load shedding orders sometimes, but needs to send out new set points every couple of seconds, and needs to receive information back in every couple of seconds. And these happen on separate devices. Now, these devices are not data diodes. They do not send a request out one device and have an answer come back the other device. Each device is a unidirectional gateway. Each device makes a copy of the ICCP server out so that the partners can pull the copy. The other gateway makes a copy of the 2 dozen partner ICCP servers back in, so the energy management system can pull the 2 dozen emulated ICCP servers. This is server replication in both directions. It's not possible to set up a command response loop that can be used for malicious remote control through these devices. We see this used, routinely. The classic use case is the balancing authority. It can also be used on in power plants. If you have a peaking power plant that needs to report power production constantly, and every second or two needs a new set point from that balancing authority saying, give me 2 more megawatts, give me 1 megawatt less. We see these gateways in and out when we need the continuous remote control. But again, they are replicating servers. Each is emulating the system to the other. It's not forwarding messages. Data diodes are routers. The unidirectional gateway is a client typically on both networks. I won't go through all of this. I'm running out of time. I did want to mention one more use case, and that is OT intrusion detection. I mean, all of the detail is in the paper I've submitted. OT intrusion detection, if we have like a Dragos or a Nozomi or a Clarity sensor that is looking at a span port, that's looking at a mirror port, we need unidirectional protection for the OT switch that is providing that data, because these span ports are all bidirectional. And so what we need is a piece of hardware in there. Hardware enforced unidirectionality. Hard isolation is the requirement from the Indian government. Hard isolation. This can be provided by a unidirectional gateway. It can also be provided by a data diode to send those copies of packets that come off the switch into the computer on the IT network that scans those messages looking for attack signatures. So I've given the 9 most common ones here, described them all in the paper. There are quite a variety of less common use cases, and I will refer you to my new book that launched 2 weeks ago. This is available for free from Waterfall Security. Appendix B in the book has another over almost 2 dozen use cases. There's 20 use cases in the appendix that apply across industry. All of the examples I've given you here are taken from that appendix. It's available for free if you go to waterfall-security.com/ the title of the book, Engineering-Grade-OT-Security. We do have challenges sending to India. The marketing team tells me that they fail in about 50% of the attempts to ship the paperback book to India. If we have trouble getting the book to you, it is available in a Kindle version on Amazon.India at the lowest price that Amazon permits, in order to get the information out there as widely as possible. So the conclusion, the threat environment has changed. We are facing almost routine production outages and sometimes even equipment damage because of nation-state grade attacks, many of them in the hands of ransomware threat actors. It makes perfect sense that we have a hard isolation requirement from this nation-state grade threat that's coming across the internet for all critical infrastructures. Optically isolated unidirectional hardware, laser photocell, that's the gold standard for unidirectionality. That is providing hard isolation while still moving the data in a way that enables modern digitalization. That was what I had for you. I hope that made sense. I flew low and fast.
Thank you so much, Mr. Andrew. I will take questions from the audience. But it is humbly put through that due to paucity of time and schedule of other presentations, you can take maximum of 3 questions from the audience. Sir, you are middle of something, so you can continue. Yes, please go.
Sir, I have one question to the speaker from NTPC. I'm sorry, I do not know your name, sir. So in your fault diagnosis, do you take only vibration signals or so you take current signatures?
No, both.
Both you take.
Processing. In fact, there's an EPRI study which has been done for pulverizer. It says that if you take only process signal, then you can find only 11% of the fault. If you take vibration signal, you can cover 17% of the fault. But if you take a combination of process and vibration, you can cover 47% of the fault. All the faults can be covered because there is a validation. So it will always be a combination of process signal as well as vibration.
Fine. Okay, thank you.
I have a question to Andrew Ginter. If I may do. Hello.
Hello.
Yeah, I have a question to you, Mr. Ginter. So as per
Yes.
the unidirectional gateways, what you're talking, that is basically you are removing the requirement of handshaking in typical communications, which any communication will have a handshaking. And that handshaking requirement, if you are able to remove, you are able to guarantee basically almost guarantee rather any attack, because attack will always have a bidirectional communication. But my question is that many applications require high latency. So how is the latency aspect taken care? Suppose I've got real-time data with me, with or without timestamp actually. So if I use the gateways in between, whether the latency requirement can be taken, has any study or some pilot has been done with respect to the latency which is lost by using a unidirectional gateway?
Yes, so good question. 2 answers. The direct answer is the gateways are used in a wide variety of applications, and the Waterfall produces these gateways. I can only answer that question for my gateways, not sort of the general unidirectional marketplace out there. But everything that Waterfall produces is produced because a customer asked for it. And so we have whatever latency is needed by the customers that are using this. If you as a customer need something different, let us know, and we will update the product for that. But let me say as well, and to give you a direct answer, the latency tends to be between 100 and 500 milliseconds on average, depending on the protocol. Something like a Pi server is generally around 100 milliseconds because the updates are event-based. If you have a polled system, you tend to have higher latencies. If you're polling like once per second, your latency is half the average latency is half the polling period. But in a sense, a different answer is this technology doesn't, unidirectional technology generally is deployed at consequence boundaries, at the boundary between 2 networks with very different worst case consequences of compromise. And that is not the connection between, let's say, a PLC and a power plant and the HMI. If the PLC misoperates, it can damage equipment or cause safety issues in the power plant. If the HMI tells the PLC to misoperate, it can also cause those same consequences. And so that network is at the same level of consequence. You generally do not try to deploy a unidirectional gateway into the middle of that network, all of which has the same consequence. We deploy the gateway almost always at the IT-OT interface, or increasingly, there's a use case between OT and the internet for cloud connections. And so at that level, if we're going to send information into SAP, SAP regards real-time communications as a latency of, no more than 30 seconds. Okay, well, we have 200 milliseconds. That's fine. And so when we get out to the enterprise network, the hard latency requirements that we have inside the critical network, in a sense, go away. I hope that made sense.
Yeah, thank you.
Thank you so much, sir. Now,
I have one question.
Yes, please.
This is to the presenter from Universal Automation. How does the effort of Universal Automation differ from open process automation? The reason why I'm asking is some of the players like Yakugawa, Phoenix are they're boarded onto the both efforts. Is it that the vendors are keeping their fingers crossed? They don't know which of the efforts will prevail.
No, no. Can you hear me?
Yes.
To answer your question, absolutely not. That's not the reason they are members of both. The two initiatives are very complementary. Let me try and explain how. Universal Automation is a technology to build an automation system using libraries of plug and produce software components. Okay. Universal Automation does not define an information model for an oil and gas refinery. That's what OPAF does. Okay. But what OPAF can do is once the OPAF specification is complete, someone, OPAF, a member of OPAF, a member of UAO, could create a library of software components to make a universal automation device comply with the OPAF architecture. Okay, so in fact, universal automation is in a way to accelerate the implementation of other open standards like OPAF, like MTP, like Namur Open Architecture. Okay, so we are very focused on the control system, a modern architecture, hardware software decoupling. You can create libraries of software components to implement another standard that is defining some sort of information model, some sort of data structure to perform a particular task. Okay, so in fact, universal automation is complementary to OPAF and is a way to accelerate OPAF because you can actually use a library of software components to implement OPAF on top of any universal automation controller. Okay, is that clear? Mm-hmm.
Yeah, thank you.
Thank you so much, sir. Now request our session co-chair, Lieutenant Nandi, to kindly sum up the session with these closing remarks.
Thank you. Good afternoon, Chair and distinguished panelists and dignitaries here. Today, in this summit, Gets to 2023 organized by NTPC, I'm very privileged and happy to be here as a co-chair. The topic is very, very important and very, very contemporary because four things are mentioned here that we want reliability, right? And in this age of digitalization, automation, and the cybersecurity, how this reliability is achieved or accelerated. As you know, as we are witnessing day by day that in today's interconnected world, digitalization is no longer a buzzword or fancy word, it's a de facto standard. The companies and the organizations are leaving no stone unturned to infuse various components of digital into their business ecosystem to make it very unified, integrated, secured, agile, and resilient business ecosystems for its own stakeholders and the customers. Now, when you talk about reliability, what does that mean? In simple terms, it's a confidence factor which is built into a system and which actually meets the criteria of some predefined SOPs or metrics and which runs without any problem or any intervention or failure. When it comes to digital reliability, because digital is infused into it,
It helps to asset and the plant monitoring so that companies can have the efficient system in place. Contemporary digital solutions rely on real-time data, as we have seen during various sessions here, and which helps us to make our system more robust and gives a lot of analytics, predictive maintenance, and various AI ML and various models which you can train and get the benefits. So this is the reason why, digital automation and cybersecurity, these are today, the common thing in IT projects of all companies. So we have seen various discussions. The session started with a very beautiful introduction and use cases by our chair about that digital automation and cybersecurity, while he emphasized on digitalization and various automations which are being done across the globe in the country and in our public sector, especially in NTPC. He has stressed upon various cybersecurity things. He has actually given some example of how fly-by-wire has been stopped now, because there are ample chances of various cyber attacks nowadays which are possible. Actually, there are groups, two groups in this world. One is good actors like all of us, and there are malicious actors. So only problem is they are very, very coordinated, very, very coordinated. That's why you see very coordinated attacks. And more importantly, the same kind of tools and technology which we use for our industrialization, digitalization, and digital transformations, the same technology is also available with them. So he has given very beautiful example of, cheap automation softwares, how it can actually, the cybersecurity, if it's not properly seen, how it can break the entire system, because thickness is the main thing, which by altering the frequency that can be damaged. He has also given very important this thing of pipeline busting. Then he also talked about gas-driven transformation, transformer. There also, what are the cyber attacks which are possible? And we have been discussing, before this session about the growing threat, which is insider threats. In fact, he has beautifully touched upon the insider, the machine itself. We think that machine which are connecting out from outside through various APIs, those can go rogue. But what about our own internal machines which are on APIs? So whether you are actually protecting our APIs, because these APIs are, the vehicles for actuating many read and write commands. So he has beautifully, covered that. And then he stressed upon the very requirement of security mechanism. What are the security mechanisms in IT and especially on OT? And we have seen OT earlier, it was very much air gap, so problem was not there. Now it's for the business reasons, this IT OT security interface is growing, because my business needs the data for empowering me to see where my problem is in my logistic, where problem in production, in fact, for customer satisfaction. So that is the requirement of the day. So we can no longer keep it isolated. So what are the security mechanisms we are keeping? Whether we are, adopting a very general zero trust approach about access control A3, access control through authentication and authorizations. So, and what are the SOPs we are following or not? So you beautifully actually, covered that one, because we know that for especially for OT system, various pattern parameters are, whether it's industrial control system, SCADA or DCS, or for any automation for that matter, the parameters of various equipments like, density, temperature, pressure, RPM, or switches on or off, these are very, very important. If through IT or for other means, if those can be altered, this can be devastating. So that's, he has also talked about the security mechanism. It was followed by the presentation by Mr. Amol from Aveva. He has shown that how digitalization, various kind of digitalization, starting from digitization. In fact, we started with computerization, then IT, information technology, information communication technology, ICT, and then digitization and digitalization. These are the journey. Digitalization for me, it's not particularly a technology. It's actually an experience we create, an efficiency we create, the effectiveness we create using the very modern state-of-the-art information and communication technology, including AI, ML, blockchain, and many others. He has also mentioned about various typical scenarios of green project, then brown project, and running project. How do you do this digitalization? How do you retrofit because it's much easier to do it in greenfield than the brownfield. And various challenges he has mentioned about data silos, how it actually impacts a total unification of the processes and giving a value to the corporations. And then project monitoring, resource management, operation management, all these challenges as he has mentioned. Then, of course, about report, dashboard, and analytics. He has actually charted out a very beautiful vision from doc to data. Data is the world. Data is the new oil, new currency. Data is a source of information. Data is the destination. Data is everything because it can make or break the entire world. So the data, when this transition from document to data, it means you are actually unifying and the unified data along with the process and the applications, software application, all this put together, you give you the very practication of digitalization is the view by which you can actually take a decision. And these are very, analytics which are not only very static analytics, this gives a predictive, prescriptive analytics also. And he has mentioned some of the cases like data like master tag registers, P&I, electrical data, and all these things for the integrated engineering and design platform. And then also he has also elucidated how this 2D and 3D data is can be captured and being captured. And the center is in asset, because in automation or for a process control, asset is the core around which entire process hovers around and it creates value. So, and then also he has mentioned about various plant structured and unstructured data, then transaction data and the real-time data, how this combo is making it possible, very efficiency in the process system as well as data analytics for decision making, and which includes prediction also. And it's actually a design versus actual operation. So this is helping them to actually see whether the operation is actually happening as per the design and to take corrective actions if something is not in place. And he has also given the case studies of DVC and for digital transformations and what results have been achieved. In a nutshell, it was a very beautiful presentation on the topic. It was followed by very nice presentation, very informative presentation by Mr. Sarangpani, NTPC, about what are the various digital initiatives in NTPC. And in fact, he has mentioned various digital and the various first which have been done in NTPCs, nicely presented. And he has also touched upon on digital roadmap 2025 for NTPC, which the motto or the goal is safety, timely delivery, reliability, sustainability. In fact, the theme of this conference is actually sustainability, reliability, how my system can be reliable on continuum, how my system, my stakeholders, my society, the entire world can be sustainable. I can keep on going that, and my efforts are sustainable, which will not fall down. I am resilient to come back. And the entire world is about sustainable reliability, and he has actually shown that how it is the one part of this goal for NTPC's digitalization 2025. In fact, he also talked about profitability and then customer value. That's very, very important because customer is the main motto. Customer is the core. Our business starts with customer, hovers around, circles around the customer, and ends with the customer. So customer is the purpose. So he has also talked about this meeting the goals. What are the various parameters? And predominantly those are data, advanced controls and automations, and then predictive management, analytics, decision making. And he has also presented what was the as-is process and the to-be process, and which all processes have been already completed, which are also running, and various things he mentioned about cloud analytics, applications, whether it's a mobile or web application, then integration platform, very important, and data lake, that is for removing the data silos problems, and then RPA, IIoTs, and ERPs, how they implemented in 2000, I think 7 or something, and then DCS, SCADA, all these things are nicely presented, and then ECM and Office 365 suite also, and of course he has also shown what are the future of March 24, which other things will be completed and which will be completed or being planned, being done for March 25 also. And 2 or 3 major cases he has mentioned about success, digital success, One is advanced process control using of artificial intelligence, and this is for accelerating the efficiency, how efficiency has been increased by implementing this one. And he has also mentioned about asset inspection, how diagnostics have been more easier by this kind of digital infusion in NTPC system. He has also mentioned about asset health index, and he has also explained the ML algorithm, how anomalies are detected, and various such initiatives. And of course, on request of chair and all of our request, he has also briefly touched upon this IEC 62443, which is the de facto standard now in the automation industry, which is, and he was a member for 3 committees: patch management, account management, remote management. You know how important is remote management. If it is not properly controlled, how it can devise the entire system itself. Account management is very, and I already talked about A3, which is access control, authorizations, and authentications. And another is patch management. Many a times we underestimate this patch, because patch is something it's need to be done in every computer which has got some software or firmware or onto it, starting from our endpoints, starting from our various security devices, network devices. These are very, very important. So he has briefly presented how he was a part of the member and part of that committee, and how this was, and this has become a de facto standard. And it's a very, very informative presentation by Mr. From Sanagopani from NTPC. And then we also, I think there was a question how image comparison being made, that is underway. And these are all possible today using AI ML. And we all know that, we can now do all these models, we can train, retrain, retain, and ultimately it can be seen, it can actually, find out the anomalies between, now he has told about 10 days, it can actually make show the anomalies of any number of image for a particular purpose. So that is underway by NTPC. The next presentation was from by Mr. John from Universal Automation. It was a very nice presentation on automation. And he has mentioned about, digital, how is acting as enabler or empowerer, I would say, for everybody, all of us in this world, and especially in business, and how he say, emphasis on green energy. We know how climate change is impacting our world and this earth, and it's going to grow. So what is the acceleration which is required to be done? The space is not enough, we have to be accelerated. So he's talked about the sustainability and affordability of energy transition, and CCUS is nicely covered on CCUS, and towards for net zero commitment. And we have got every citizen, every business organization has a very distinct responsibility on this mother earth. And he has also, mentioned about challenges for acceleration and what are the various identified trends in this regard. And he's also touched upon the key improvement areas, GH2 business value chain, how one is renewable energy, how to scale up, how to de-risk, and then the safety operations and efficiencies, and what are the flexible operations which are possible here. And he finally talked about automation modernization, how it is very, very important. Because how our automation system will be modernized, because now automation is talking to automation, machine is talking to machine, more machines are talking to machine than human is talking to machine, or machine is talking to human. So how these are to be made vendor agnostic, platform agnostic, how it should be made portable, so that I don't have to reinvest, I don't have to reinvent the entire wheel or redesign or redevelop the entire system. And reusing of software is very much important nowadays, not only for automation software, entire IT, OT industry, reuse of software is very, very important. And this has become much more simpler use of LCNC, low code, no code, and various tools which makes it possible. And he has also talked about various modern components and OOPS based, which automation system has to, object-oriented programming system has to be infused here more and more. And reusable libraries, which actually brings down our time of development, and which facilitates quicker time to market. And he also talked about that OT world has to learn many such things from the IT world, and younger engineers in business to be welcome more and more. And he also talked about universal automation org. There is a platform, it's making a standard. Many companies are into it, which started with 9 members. Now I think it is 66 members. And there's a community of users and vendors. And he has also given in one example I can mention about the Brilliant Planet, how the examples of CCUS, a very, very nice presentation on the topic. Thank you. And the last one, but the not least one, it was very, very important one. And in fact, we all talk about digitalization, all other operations management or automation based on digitalization. But the most important thing is cybersecurity. Gone are those days where cybersecurity was treated, whether in IT or OT, as an auxiliary or some kind of, maybe may not be their kind of option. But now those days have gone. We cannot, not a single day when you don't hear any attack around the world, with the various kind of attacks, predominantly ransomware attacks, OT attacks, and various such attacks through social engineering, phishing. There are different kind of phishing nowadays. Almost 22 different phishing types are there. I mean, the way cybersecurity has, the attacks have increased. So he has nicely presented about the use cases where cyber attacks with physical consequences. And impact is because it's exponentially growing, and it is growing, and its acceleration is tremendous, and by 2027 it will be catastrophic if proper measures are not taken place. And he has also talked about threat environment, ransomware, nation state, that we have been quite often we are hearing that how state-sponsored attacks are happening in by one country to another country, and most importantly, these are critical infrastructure. And now CI is no longer a CI, it has become a CII, because critical information infrastructure. Nothing can run without information, nothing can run without digitalization. Though protecting the CII is very, very important for any countries. For us, is power, energy, and other various sectors have been designated in India, the government of India as a, and as an extended arm of the government. All PSUs are the extended of the government. We are onto this so that we can continuously protect our environment. He has already, talked about what are the impact on these attacks in terms of money, damage, reputations, and in fact, shutting down the critical information structure, which will be very devastating from the organization point of view as a nation point of view as well. He also talked about how earlier it was aircraft, so there was no, interface between IT and OT. Things were not so dangerous. But now, since due to business process, business requirement, IT has to be connected to OT, rather OT has to be connected to IT. What are the various options available? He talked about unidirectional gateway. It is like a diode. We know in electronic diode, the current flows in only one direction. So it will actually flow from, that's what his proposition and very beautiful explanation was, that data has to, from the OT system, how it will be safely taken outside, but not other side is restricted. Even whenever, if somewhere, the control, the two-way handshaking has to be done. So that on a query, he has also nicely explained that how that can be done. And he has already told about some use cases where, safe IT OT, outsourced security operating center, I think both on IT and OT, and then remote vendor support, dispatch and balancing, outage management, OT IDS, intrusion detection systems, and so on. And so this is how he has actually told that how the waterfall security solutions can be very much beneficial for entire industry. And he has also talked about a book on waterfall security. Lastly, which let me see, I will also go through that. So a very brilliant presentation. So by and large, the entire session witnessed a very, very informative discussion and questionnaires on how we can make our system reliable. The goal is the reliability. Digitalization itself will not give us reliability. Digitalization is the tools and techniques, and using this PPT. PPT is not PowerPoint presentation. PPT is people, process, and technology. While we have got a lot of technologies, how we are infusing process, digitalization the process to make it very, very secured. And lastly, the people, because people are only the who actually operate this entire system. This entire PPT has to be secured, and that is how we can actually achieve our reliability and sustainability. And digitalization and automations are growing in continuum. Many things will come. We have seen Industry 4.0. People are talking about Industry 5.0. It is beyond the smart office or smart factory. It is now how my machines will help the humans to do a very phenomenal job for the society, for the corporation, for the customer. So with that, I conclude my summing up. Thank you so very much.
It was indeed a great session where our experts shared their knowledge upon various aspects on the theme digitalization and automation, including cybersecurity for reliability. It will be a great honor for us to now felicitate our dignitaries with a token of love and respect.
I now request our session chair, Sri M.A.K.P. Singh sir, to felicitate Sri Amar Dhale sir with a memento from us.
I request Sri M.A.K.P. Singh sir to present a memento to Sri R. Sarangpani sir.
I request our session chair to kindly felicitate Sri John Conway. But as he is online, I request Sri Somaji sir to kindly collect the memento on his behalf and will send him to.
Our eminent and luminary speakers online, I will personally make sure that these mementos reach you.
Thank you very much.
I now request M.A.K.P. Singh sir to kindly felicitate Sri Andrew Ginter sir with a memento. I request Kundu sir to kindly take the memento on behalf of Ginter sir.
Thank you.
May I now request our session chair to present a memento to Mr. Litin Nandi. Big round of applause.
I now request our session co-chair, Sri Litin Nandi sir, to kindly felicitate Sri M.A.K.P. Singh sir with a memento.
Also, Mr. Litin Nandi sir to present a memento to Sri Somnath Kundu sir.
It's okay. I request Sri Litin Nandi sir, co-chair of the session, to felicitate Somajit Mukherjee sir with a memento. Our session developers have really worked hard, sir, to make this session so nice. Thank you so much, sirs. I thank on bottom of my heart to Sri M.A.K.P. Singh sir, our session chair, our co-chair Sri Litin Nandi sir, our Sarangpani sir, John Conway sir, Mr. Andrew Ginter, and our session developer Somnath Kundu sir, Samajit Mukherjee sir. EDPMs have joined us, sir. Welcome to this session, sir. And all the dignitaries present here and online में भी जो भी जुड़े हुए हैं हमारे साथ, I really thank all of them to be actively participate in this session. We can close this session with permission of chair. Thank you so much, sir. I invite the next session to kindly start, please.
Just 1 second. I would like to address John. He made a remark to CA cybersecurity guidelines actually, and the requirement of hard isolation was from our Honorable Minister of Power actually, and he stressed that this should be there actually. And if we can ensure it, we can ensure 90% of the cybersecurity, but that's not happening. Thank you.
काम होता है वीडियो चले
Hello. We are forwarding with our next session topic, which is R&M challenges, perspective, and way forward. Regarding the context of the session, I would like to brief a little about this R&M challenges. This R&M of power plants is essential for maintaining their operational performance, aging infrastructure, and increasing operational stress on the equipment leads to significant deterioration in power plant performance. Besides, in recent times, there have been preparing themselves for flexible power plant operations owing to large-scale renewable energy integration into the grid. Through R&M interventions, the performance of traditional baseload plants can be maintained even under flexible operations. Further, modernization and upgradation of thermal power plants is required to meet the tightened emission norms. In the hydropower segment, R&M can help in quickly adding capacity and improving plant reliability. With this, I would like to invite our session chair, Sri Vikas Chandra Malik sir, on the dais for the session. I would like to give a brief introduction about Sri Vikas Chandra Malik sir. He has a vast experience of power sector. He was instrumental in policy design, study, test, implementation, and coordination in achieving minimum technical load of coal-fired generating units for low-cost integration of solar and wind energy. He has initiated countrywide 40% load operation pilot tests, which demonstrated the low load operation capability of coal-based generators. He has also published a comprehensive report on flexibilization of coal-fired power plants, a roadmap for achieving 40% technical minimum load, which includes operating procedures for low load tests, actual field test data, challenges, measures, retrofits for flexibilization, efficiency lots, capital expenditure, operational expenditure, compensation, tariff impact, etc. He has also played a pivotal role in preparing guidelines, viable business model, model building documents, etc. to improve performance, life extension, compliance of regulatory norms, safety, cybersecurity, etc. Sri Malik sir had prepared a plant location specific emission standard for smooth implementation of FGD systems in coal-based plants. He has also played a role in promoting R&D initiatives and Make in India initiatives to develop indigenous substitute product for which power sector depends on imports. Sri Malik sir is graduate in electrical engineering of 1988 batch. He is presently holding the principal chief engineer in Central Electricity Authority, India. I welcome you, sir, with your wide, diverse working area and experience as a session chair. May I now proceed with our session co-chair, our very own senior leader, Sri S. N. Tripathi, sir. Sir is currently working as Executive Director, Project Management, as well as Regional Executive Director, Hydro in NTPC Limited. His experience in power sector spans over more than 35 years in operation management, maintenance, as well as project management. Currently, he is managing NTPC project portfolio of more than 12 gigawatt under construction, and approximate 6 gigawatt of projects and more than 60 gigawatt of FGD projects. He has also been entrusted with the additional charge of Regional Executive Director of Hydro of NTPC portfolio, where he is actively steering the energy storage viability analysis and working on faster execution and future capacity addition of pump storage power plants of NTPC. Prior to appointment as EDPM, he has worked as business unit head of NTPC BARD, which is one of the most challenging and complex projects undertaken by NTPC in its history. He has also successfully managed other challenging projects like Major and BRBCL. It's my honor, sir, to invite you being on the dais as a co-chair of this session. Now, I would like to add on our next session presenters, one of whom is Sri Bhaven Onto sir. Due to his sudden change in health conditions, he has left the premise and he won't be available for today's session. And we wish you be very good, sir. Now our next session chair is Sri Shekhar Thakur, sir. Sri Thakur, sir, is head of sales consulting team within GS Services, division of Siemens Energy, leading technical sales and business development, activities for thermal power plants, R&M, and plant performance assessments. He has about 22 years of experience in power sector with diversified technologies, having worked with major power OEM companies, example Siemens Energy, GE Power, and Alstom Power. He has expertise in driving entire life cycle of products and projects with extensive experience in new product development, tendering, execution, and customer service for service upgrades, core services, R&M, and new equipment project for steam turbines and related systems. In his presentation, he will cover the R&M of steam turbines and its systems. I welcome you, sir, on the dais. We would like to hear your views and your experience in this regard. Our next presenter is Sri N. Sairam from BHL Trichy. He has more than 10 years of experience in power sector. He is a graduate in mechanical engineering from PSG College of Technology, Coimbatore. Presently, he is working as deputy manager in project engineering division of high pressure parts division of BHL Trichy. In his paper, he will discuss about Enrich, that is the cold stability burner for tangential fired thermal power stations. Due to some personal reasons, Sri Sairam could not join, and his place, Sri Pritam Kumar, sir, senior manager from BHL 3G, is also the co-author of this paper, will now be presenting this paper. Sri Pritam Kumar, sir. Our next presenter is Dr. Sivaji Sipana. He is a PhD in chemical engineering from IIT Madras, Chennai, in the area of oxy-fuel combustion. He has experience of over 11 years in coal research, SCR, and boiler designs. He has also expertise in CFD flow modeling. He is currently working in boiler design department, BHL Trichy. He has published more than 10 international publications and more than 10 conference papers. He has 12 Indian patents in his name covering various topics in sustainable energy sector. In his paper, he will discuss about optimal methodology for implementation of biomass co-firing with coal in coal-fired thermal power plants. Sir, I welcome you on the dais for sharing your knowledge. Dr. Sivaji Sipana, sir. Sir, please. Our next dignitary on the dais is Sasish Kumar Sharma, sir. He has more than 15 years of experience in power sector. He is a graduate in electrical engineering. Currently, he is working as Deputy General Manager in Station Engineering Division of NTPC Limited. In his paper, he will discuss about various aspects of R&M and probable business model for implementation of comprehensive R&M of thermal power plants. It will be a pleasure to have you, sir, on the dais. Please take a seat. May we have a round of applause for him. Our last presenter, but not the least, is our very own Anil Kumar Das, sir. He is GM Netra. He has joined NTPC R&D division in 1992 and is a qualified professional in NDT techniques like ASNT level 3 in 4 non-destructive testing techniques. He has also acquired CSWIP level 2 in PAUT and ASNT level 2 in visual testing and RT testing. He has been involved in more than 400 health and life assessment studies of power plant components and has played significant role in introducing many advanced NDT methods in NTPC. He was awarded National NDT Award in 2011 by Indian Society for Non-Destructive Testing for outstanding contribution for industrial application of NDT. He is a life member of ISNT, member of ASNT, and also a member of National Certification Board of ISNT. A graduate and postgraduate from IIT Kanpur, He is currently working as General Manager in Netra Division of NTPC Limited. Netra is our R&D department where research and development works of NTPC are being taken up. In his paper, he will discuss about various NDE and online monitoring and diagnostic tool to have increased coverage and reliability of the inspection to detect and ensuing originated defects in various components, to take timely action and for failure analysis of various components of power plant. Thank you, sir, for joining us. With this, okay. I would like to invite Sri Sripanna sir, Dr. Sivaji Sripanna sir, please. Okay, sorry. Sir, with this, now before we begin our session, let me give a brief context about our session.
The Renovation and Modernisation Programme for Thermal Power Plants.
R&M program for thermal power plants in India are more than 35 years. In initial years, the purpose of R&M was to increase the performance of the old power plants. Thrust was also put to increase the reliability of the plant and to increase the operational life. In subsequent years, in addition to performance and reliability concerns, environmental concerns also started driving the program. In last few years, dependence on renewables is growing and is destined to overtake fossil fuels in future, considering the India's commitment towards the achieving the net zero by 2070. However, conventional renewables like solar and winds are intermittent and would require energy storage devices to provide power 24/7 around the year. Non-conventional renewables like geothermal, ocean thermal, wave energy, etc. can provide the solution and act as base load. However, these are yet to mature on economical scale. These above scenario, coupled with environmental concerns, is putting up new challenges to existing thermal power plants and opening new frontiers for R&M. R&M for efficient and reliable operation of a plant with carbon footprint. With this, I'd like to show a small brief introductory video about this session.
The Renovation and Modernisation Programme for Thermal Power Plants in India has been in place for over 35 years. Under this programme, the thermal units are equipped with the latest technologies to improve their overall performance and efficiency. It is a low-cost solution for adding generation capacity over a short gestation period, as against setting up a new plant. Renovation and modernisation also reduces forced shutdowns, resulting in higher uptime and higher revenue. The initial objective of renovation and modernisation was to enhance generation from the old thermal units and extend their useful life. Today, renovation and modernisation practices are being adopted to reduce the environmental impact of thermal units and adapt to the changing energies. Thus, the key growth drivers for renovation and modernisation are tightened emission norms, ageing plants and flexibilisation requirements.
Considering this time constraint, I would request all the session members who are presenting their papers to please restrict your time limit to 10 minutes for your papers. Now I request Sri Vikas Chand Malik sir, our session chair, to conduct the session, which would be definitely a memorable session and learning for all of us. Over to you, Vikas sir.
January this year, on advisory that not to retire any old plan, thermal coal-based generating plant, and advised to run that unit, those units, up to at least 2030 or beyond that. Because that time we received some
from utility, few units they want to retire at least about I remember more than 10 gigawatt in this year. So why so? That because our prediction was that by 2030 that the demand, what is the demand projected by CA and generation balance, maybe there may be a shortfall. So, but in this year, what we have seen that all the prediction actually break, means this year demand met. What is the met demand is in April 2023 is about 140 gigawatt, more than 12% increase in the demand side. So now we are planning to establish, means a new thermal plant, as well as what is the old thermal power plant is there. We want to revive or means continue to generate up to 2030 by intervention of RNM. In this regard, today this workshop is very important, because why we are going for RNM? Because RNM we can revive that unit's efficiency or all operating parameter up to the design value or even more. In case of heat rate, we have seen in Ukai and also in Ramagondam, I think, that heat rate has been achieved by RNM. It is more than, means it is below the design value. So by intervention of RNM, we can achieve more efficient units, though it is old. Also, the that units already fixed cost has been recovered or being at the very means being recovered. It is in almost nil. So only operating cost is there, so that it is commercially viable. So further few things we have seen that some regulation from the part of MOFCC in that environmental compliance have to be made. Another thing is the from Ministry of Power that we have to implement the co-firing, biomass co-firing, that 5% that have mandate is there, that has to be complied. Another thing is the CA flexibility requirement, 40% by 2030. That phasing plan also being prepared already. It is under notification. This month or next month it will be notified. Each unit about out of 600 units, we have prepared more than 500 that have to be complied with the 40% flexibility and required RAM rate. That between 40 to 55%, 1% RAM rate is required, and 55% to 70%, 2% RAM rate has to be there, and from 70 to 100%, that is the 3%. That RAM rate also be met, because all this thing is being made for the RE integration, targeting 2030, that about 392 gigawatt solar and wind capacity will be in there. So to facilitate the integration, that RAM rate is required, and also the flexible operation. Another thing is the MOFCC notification that ESP upgradation or the FGD implementation or combustion modification for meeting the limits of SPM, NOx and SOx. All these things, if we implement this thing, that has to be RNM, means by retrofitting or only retrofitting we can do this thing. So this is also RNM. RNM, another thing is that we can extend the life about 15 years, minimum 15 years we can increase. So it is required. And some challenges. Today we will discuss also challenges. challenges means we have seen that few units, old units, how we can achieve the 40% in that units. Also, we have some CFBC boiler units also there. Can they operate at 55% or 40%? Some units in the India the operating under that is a ball and tube mill is there. That's especially old unit, 210 megawatt. That units are operating 3 mills with full load. Can it possible to run that 55% or 45% load that there? Another question is that suppose old units are not capable to operate as per the regulation, it's 40% or 55%, then few units can it be possible to operate at two shift operation? That question is there. BHL is there or Siemens is there, so they can also highlight this thing in their presentation. I request them these challenges there, so solutions should be there. With this, I request to please carry on this presentation.
Sure, sir. So we shall start our presentation with Pritam Kumar sir. Or shall we start, sir, as you wish? Malik sir. Yeah. Shall we start? Whatever you say, sir. Whichever session you need first, I will roll on that one first.
No, actually, I don't have any list. So, okay, topic is the same, no?
Yes, sir.
So we can as per your list.
Sure, sir. We'll do that. So we shall start with the presentation from Pritam Kumar sir. Yes, sir. We'll have our question answer at the last after all the presentations were done.
Yes.
Good evening, gentlemen. Today's topic for Indian business. We have given this topic, and we have been always a new component developer for the R&M business. Let it be a R&M or the retrofitting of greenhouse systems or stabilization of the boilers. So today I brought a presentation regarding this, in which whole stability boilers, which talks about the flexibility in the boiler from fuel systems perspective. So we have developed a new type of burner, coal burner, which can operate at low loads. The team members, we have Sairam, myself, Pritam Kumar, Sachin Kumar Srivastava from Corporate R&D, and G.S. Arun Kumar. We have been doing this project for maybe 1 year or so, and we have been successful in doing things. So it's a project which deals with burner which can operate at lower loads. Now, presently, we have the scenario, the current market scenario is like we have rise in the renewable energy. So whenever there is a energy available through renewable sources, grid is asking the thermal power plant to reduce their power. And this variability is a lot during a 24-hour day. So most of the time, maybe 7 a.m. to maybe 6 p.m., this will be at higher peaks. And then you have the other loads to be reduced. For example, so for this, the boiler has to constantly adjust to the grid requirement. And also, because of this adjustment, there are chances that frequent flame failure trips will happen. So to reduce this, obviously the thermal power plant will take the support of oil. So as you all know, the CA regulations, like the minimum load of the thermal power plant should be taken to minimum 40%, and which are running at 55%. Within 1 year of notification, they have to come to this level. So what is the challenges we are getting at the for operating the boiler at the low load? So we are designing a boiler for maybe, for example, 3,000, 3,500, or 3,000 at a higher calorie value. But whenever it comes to the final or actual values, it is very low. Maybe it is going to a range of 2,800 also, and below that. So because of this, the operation of the boiler cannot be very low loads. It is very difficult. At the same time, you require the oil support to do this. And because of the coal characteristics as well as the boiler parameters, you have the higher chances of flame failure because of the coal. And because of the oil, you have to take the oil support during the low load. Okay, so what are the factors which are affecting the flame stability in thermal power plant? So first 4 or 5 of the 4 are things which are connected to coal, which we don't have any control. That is the volt matter of the coal, the heating value of the coal, the ash content, and the lean fuel air ratio. Because as the fuel ratio is reducing, the volatile matter is reducing, the quality of the coal is reducing a lot. So at this time, we don't have any control on the coal. But the other points like fineness of the coal, the imbalance in the coal piping system, and flame scanners, which are there in our. So, for example, the fineness of coal, you have to tune the mill to get the required level of fineness, and balancing in the coal piping so that uniform coal is going into the furnace. Again, the flame scanners have to be tuned so that it is seeing the flame at the right spot where the actual burning is happening. So to take care of all these issues, we have developed this new enriched burners, so that they ensure that there is a good mixture of rich and lean mixture, and they are separating a lot and giving at a constant place in the burner panel. It ensures that the air ratio is at the rich air coal ratio is available at the coal. Also, we are optimizing the scanner locations and the damper adjustments in the coal. So I'll just skip through how we have developed this enrichment and all this. We have done a baseline. From there, we have developed 3 new types of burners. And in that, out of the 4, we have got the one which was giving the best results by CFD analysis. So this is a model which we have created, in which the FIE, the coal nozzle, the tips, and also the air nozzle tips were also modeled in a compartment, and it was CFD analysis was done. If you see, this is the conventional coal which operates in almost most of the boilers, and we can see the different patterns of the analysis, wherein we can see base 1 is a conventional coal and the other 2 are there. But variant 2 was showing a different perspective in which the coal was the flame was there near to the coal burner. This is the other one where we have the low volatile coal. Still, the temperatures are low, but the flame is stable at the location of the burner pan in variant 2. So this is the particle size distribution in the coal nozzle and its tip. And this is a 3D model of the enriched coal nozzle what we have in them. So only words and no action will not serve purpose. So we have taken this and manufactured and then tested in one of the power plants in Tuticorin, and it was tested in all 4 loads, 100%, 55, 40, and 40%. And all these loads were done without any solid support, and the flames were very stable. Actually, we are confident that it can go up to 30% of BMCR load, but because of the TG side requirement, the power plant operator, they could not reduce the still level. And the location of the flame scanners were also strategically moved. Because of it is a BHL boiler, so we have all the technology and the renovation and requirements for that. And so we have made it tailor-made so that it can be easily fit. These are the flame scanner intensities, which were seen at 40% BMCR load. So if you see the results, now you can say that the At lower load also, the flame is stable and it meets the CA guidelines to the 40% minimum load. And we can guarantee up to 30% of the load. And with this, we can reduce a lot of fuel oil as well as the greenhouse gases generated because of the burning of oil. So to conclude this, this was the systematically developed enriched nozzles, and they are tailor-made to requirement of the coal as well as the boiler parameters and the wind box configuration. It improves the stability of the coal combustion at lower loads. Flame scanners are also statistically reoriented to take the maximum benefit of the flame available in front of the coal. And also we have done the coal flow and coal flow balancing and coal fineness ensured. Because of this, we have got a good amount in fuel oil savings, and it is easy to be done in tangential file boilers. Thank you.
Thank you, sir, for your wonderful presentation and sharing of your knowledge with us. I would like to invite our next presenter on the R&M challenges, perspective and way forward by Sri Shekhar Thakur sir from Siemens Energy. Over to you, sir.
Hello, good evening, everyone. I'm Shekhar Thakur from Siemens Energy. I'm going to present a few topics on R&M challenges, mainly for the steam turbine and the rated systems. From the OEM perspective, from the Siemens side, and I have few experience from my earlier companies also. I have been working with GE earlier, so I would like to present something on the OEM perspective. What are the R&M challenges the companies are currently looking at? Just to set the context first, so with the R&M, we are looking at the three main, key technology needs that we have. One is the performance, which is the foremost, the heat rate improvement, the efficiency improvement, the flexibility, which is now coming into the picture with more and more, low load operation and amp rates, the requirement of the power plant to operate at a flexible load. This is something which coming into the picture for steam turbine also. Although steam turbine technology is slightly advanced as compared to boiler in terms of flexibility, but yes, that is something which is still required. And reliability, which is the basic requirement. That whatever you're doing, the unit should keep operating in a reliable way. So you have to reduce the force outage. The availability should be high as much as possible. So the drivers for the R&M, as we say, improve power plant profitability, right? So we need to have more efficiency, lesser heat rate, less coal consumption with the same power output. So this is the basic requirement. The fuel cost we want to get reduced. Second is the lifetime extension. Some of the critical components like rotors as well as inner casing, which goes into operation at a very high temperature, let's say up to 540 for a subcritical unit. They go for a creep damage, and the lifetime extension is quite critical for them. Also, the outage optimization is one aspect that we look at for each of the R&M projects, because this is the generation loss. Direction and commissioning of a typical R&M may take from, let's say, 100 to 130 days, which is the generation loss for the utility. And it's important that the solution that we are providing, it takes care of the outage optimization aspects also. So just a quick comparison, if we compare about, when we do a regular inspection repair for a particular component or a component exchange, when a full module can be replaced or a rotor can be replaced. So if you look at the top chart, which is on the orange bar, orange bar here, it shows the level of investment that our customers are doing in. So you have the inspection and repairs, you have annual outage, you have the COH, which is going on every few years. You have some level of investment, that the cost that goes into it. Then you have the component exchange, which is the spare parts or some kind of a critical component exchange also, like the complete rotor. So the investment are higher. But if you look at the requirement or look at the gain, that the value for the customer that they are there. So with the inspection repair, they are getting something about the reliability improvement, right? With component exchange, they are getting lifetime extension also along with the reliability. But if you look at the R&M, the modernization part, which is slightly higher cost as compared to the component exchange, you not only get a higher reliability, higher lifetime extension, but you get the efficiency,
you get the flexibility, and you have the sometime capacity enhancement also. Like the NTPC Ramagundam RNM that was done, there was a capacity enhancement also done there. So if you compare inspection, component exchange, and modernization, you see the value that our customers are getting with the modernization is much higher as compared to the other smaller aspect that we can look at. So next I'll move into some kind of a scope that we look at for the RNM. So some of the units that have undergone this RNM recently, with the LMZ 210 megawatt units, right? So upper part is the existing cross section, and the lower part is the typical RNM solution for such units. And this has very comprehensive scope of work, right? What has already been implemented also. So if you look at the cross section, you will see it requires a complete replacement of HP module, complete replacement of IP module, the LP inner module replacement, as well as other specs like HP IP walls, bearings replacement, a lot of scope on mechanical auxiliary systems, and you need the new turbine controller as well, right? So it's a very comprehensive scope that is required for a LMV make unit that we have seen. And recently, it has been implemented on Ukai Unit 4 and Wanaguri Unit 3 by GSECL. Under execution, Ukai Unit 3 and 5 under execution. And then there are active tenders like NTPC Vindhyachal Unit 1 and 3, 1 to 3 are active tenders, and then Wanaguri Unit 1 and 2 also by GSECL. So there's a big pipeline. And also we see there are good pipeline with NTPC also, as well as other state boards for such kind of units. And these are the units which are the oldest one in this 210 megawatt category, as well as the subcritical category. And these are the first ones which are coming into the RNM cycle. So that is how it is. Next, I think what we see that should come into the picture is the Siemens make Carview 210 units that should come into this RNM cycle. And if we talk about the typical scope versus what we are doing for LMZ versus what we need to do for Carview, I think it cannot be a typical scope. The scope has to be considered unit-wise, the technology-wise, and accordingly has to be optimized. For a Carview unit, the typical scope that we see is only the inner module replacement. Like you have this HP, you have the IP or the LP, and you can only do an inner module replacement that need a rotor replacement and inner casing replacement, and along with other seals and etc. And you can gain the same level of performance improvement with a much lesser cost here, right? So if you look, the typical scope of work that we are proposing here is only the HP IP LP inner module replacement. The walls are something that are not required to be changed. Some of the internals can still be replaced if they have the lifetime issues. Also, the bearings, pedestal, you don't have to touch that, right? Nothing on the controller side if it is already modernized separately. Only the settings has to be updated, right? So with this, what you can gain the performance with a much lesser cost, much lesser capex, but you can also get the lifetime extension of the critical component, and also the risk associated with the interfaces and everything get reduced much less. So you'll see the erection and commissioning time for such unit will be much lesser than as compared to the LMD units. One more typical on the scope of work I would like to emphasize is the module level upgrade, which is not very popular as of now in India, but globally we have done a lot of projects, from Siemens side globally. So module level upgrade is like only replacing one module, not the complete shaft line, right? So let's say if you look at the top cross section, here we are only upgrading an HP module. So HP module can be upgraded with advanced steam path, advanced materials for the rotor as well as the casing, and you can get the performance improvement. You get the efficiency improvement of the HP, and along with that, you can gain the heated improvement. And similarly, if you look at the lower section, you'll see only an LP in a module replacement, right? Even with LP, if you have any issues related to the low load operation, let's say if you want to go like 40% operation or a lower than that, the LP last stage blade or design becomes very critical. So you can just go for an LP in a module replacement, and then you can achieve that kind of performance improvement as well as the flexibility operation improvement. So this was a typical scope that we are proposing for the Carview units as well as our experience on the global side. In India, we do have some of the Chinese make also, and these are, I think, in future these will also come into this RNM cycle. And so this is a typical cross section for a Chinese make, let's say a Shanghai make 135 megawatt unit or a 300 megawatt unit. And when you talk about RNM of these units, since these are much newer units as compared to Kavio as well as LMZ, there is a lot of component that you can still retain here, right? So we are talking about, let's say, only the inner module, again, replacements for an HIP. So this first one is the HIP, and then it's an LP module. And most of these units has come with the partial arc admission kind of concept. So if you're looking at a higher megawatt output only and you want to operate at a base load in the near future, next 10, 15 years, you can go for a full arc admission kind of concept for HIP, and then you get a much higher efficiency or much better than the original design efficiency for HIP module also. We have given some proposal in the market with this, but hopefully some projects should convert on this as well. So few aspects on the scope challenges and the concept that we are proposing. Now coming to some of the challenges here. This is our experience from whatever the tenders or the project that we have executed. I think some of the points I would like to highlight here, and hope you'll go back with some of the 2-3 key points to work on in future. One is this turbine R&M, impacting the other components like boiler. So we have seen what has been done on Ukai and Wanakburi. The turbine R&M has also impacted the boiler operation, right? So if you're also planning a boiler R&M kind of spec, it's very important that you define the scope and you define the boundary parameters very clearly, right? So this is an important challenge here. Then the next is the part load guarantees. Now, when we have the flexibility which is coming in, this is also a very important aspect that's coming to the RFQ. And NTPC has taken a lead with this in the Vindhyachal, where they have asked for a heated guarantee for the part load. But yes, in this case, I think we need a clear guideline, and we need support from CA and other authorities to have a clear guideline for the part load efficiency. How or what kind of guarantee that should be there. Scope related to EPC work, some other, and finding scope changes. This is again like how the OEMs and the customer can work together with an R&M. If you stick to the contract, there could be some challenges, but yes, I think the customer should be ready to, during the execution itself, have a detailed discussion with the OEM, try to understand if there is a better solution that could be implemented, and be ready for that. And then the supply timelines. This is another challenge, which we have the uncertain global scenarios with the wars, everything coming in. The supply is getting challenging again and again with the time. So we are currently looking at minimum of 2 years for the supply of the turbine components, which include forging coming in from the global. So this is another challenge. Few additional points I'd like to highlight. One is the evaluation method. We have the reverse auction being used by some of the state boards for selecting the L1 bidder. We have strongly recommended them that this is not the correct way to go for an R&M, best bidder selection, because that lead to very challenging, price challenges for the company, the bidders there, and sometimes it may increase the risk for the customers also with this. Right, so GSCCL is currently incorporating this for the reverse auction for the R&M, but I think we need to work on and have a clear guideline like whether we can really use this or not. Another method is quality cum cost based. This is the concept that has been proposed, and I think this is a good method to really select a good bidder for an R&M. This takes care of the past experience from the bidder as well as some of the additional things. And then we have payment terms. One thing is limited number of R&M opportunities. We see something coming from NTPC and the GSCCL, but I think the pace of R&M opportunities in the market has to come quickly, so that we have the learnings incorporated in the market itself and improve on that. Because we have like companies like GE, Siemens who are into this market as of now, but maybe if get delayed further, because after Ramagundam, the last order was done after 6 years. So if it get delayed further, there are chances that companies may opt to, to avoid such kind of projects in future and go in a very different direction. Okay, these are the things which I already covered, like policy interventions that we need. One is from the push from authorities to get more opportunities into the market, evaluation method, and then the long-term performance guarantees, another aspect that we can look at to have the performance guarantees for, let's say, 1 year or 3 years or 5 years down the line, which will be beneficial for the customer. Okay, thank you. And sorry if I extended any time.
Well, thank you, sir. Now the next we'll have presentation on optical methodology for implementation of biomass co-firing with coal in coal-fired thermal power plants by Dr. Sibaji Sipra, PHL Trichy. Sir.
Very good evening to respected panel members and delegates from various institutions. Today I'm going to discuss about the biomass co-firing in coal-fired thermal power plants. A brief introduction about the energy scenario in India. We have a large installed capacity in which you could see that there is a majority portion of approximately 58 to 59% is by thermal power plants. So, but we are targeting for a net zero emissions by 2070. Although this is too far, but we need to act now. See, if you see exclusively what is thermal content, and you could see that the majority is by either coal or lignite, and the minority is by other two, because we have abundant reserves of coal. So to meet such a big targets of net zero, we need to go on a step-by-step process, as we seen in many panel discussions, that if we go abrupt, that energy security and that total cycle will disturb. That's why we need to go on a step-by-step process for that. So one of the good thing is that utilizing the some easy retrofits like biomass co-firing with coal is one of the methodology that can reduce the carbon emissions into the net emission into the atmosphere in a significant way, but with a minimal modifications in the existing systems. But however, there are some issues associated with the biomass co-firing that we'll see in upcoming slides. Apart from this, there are other methodologies like carbon capture from the power plants. But again, you can go for a post-combustion capture and the pre-combustion capture. But these are all comes with a cost. The cost is too much for an Indian power market to bear. So that will go as much as 30% is for installed capacity as well as operating cost also goes up. So considering all the scenarios, this biomass co-firing is one of the best methods. So, but if you see the biomass, it will be like available in wide variety in nature. Like in a raw biomass, if you take it is of high moisture, and dried biomass, it is of sizes are too different to implement in a pulverized coal-fired thermal power plants. But there are ways to making it energy densified and easily handleable. So that is how this non-torrefied and torrefied way of doing the pellets, it has been there. So now that Indian market is also going into very fast in this regard, but because government of India is also pushing very fast, like by 2023, the earlier CEA guideline was to implement 7%, although now it is postponed by 2 years. But these are the limitations for the PC-fired power plants. Whereas if CFBC, if you take this is slightly liberal, you can go with the not so much torrefied pellets. Maybe non-torrefied also okay in CFBC boilers, because inherently they are designed to operate at a higher particle size than that of a PC-fired systems. PC-fired system demands an average size of 70 micron. That is a really tough task using the existing drillings and PC-fired system. So why the biomass fuel is a complex system? Just I'm just giving the details of various things. You could see here that when we see here, you could see it's same as coal, because coal is the much is a great grandfather of the biomass. Biomass is the very infant stage. The coal is the highest senior level that one could think of. So, but when we go in very closely, the volatile matter, if you see this coal has approximately Indian coal has around 20. But if you see the biomass, it varies in a wide variety from starting from 30 to 60, 70, 80 also some cases they are there. And similarly, the oxygen content, if you see, this is inherently higher and ash content is lower. Nitrogen and sulfur content depends on the type of biomass fuel. And we'll also look into this ash composition. This is another important aspect. If you see the biomass, most of the biomass fuels have the higher alkali content, the potassium and sodium, and some even have the higher the calcium, magnesium, and this iron contents. So these are all together forms a low temperature ash melting components that will reduce the ash fusion temperatures. So this may cause slagging in the upper furnace and maybe the down further down. So that is why it's a complex fuel to handle in a coal-fired power plants. A thorough analysis is required and a frequent analysis before and during the biomass coal-firing is required. And most of the points I have already discussed. And the biomass fuels also has the chlorine content, which will cause a high temperature corrosion in the superheater and reheater coil panels. So the one more aspect I would like to just cover here is that reactivity or maybe volatile release of the biomass fuels when compared with the coal. You can see there are two comparisons were given here. The green line shows the volatile release in a agro residue based biomass, whereas the black line shows the volatile release in a typical Indian coal. You could see that the volatile release has started much earlier, around 240, and it is going on. And it is the if you see the band of a temperature 240 to 480, the release has completed, whereas for the coal it has started at 380. So similarly, the reactivity of the biomass is higher than that of a coal. So these two infer as that when you co-fire the biomass with the coal in a existing mill, the fire hazard in the mill increases. So that's the takeaway from here. So, and again, it depends on what kind of a biomass proportion and what kind of a fuel, what kind of a mill system, what kind of a temperatures we are using. It depends. It's a complex function of many parameters, but the key point is that it's not as like coal, and the volatile content in the mixture of biomass and coal is increasing. So the mill fire hazard is increasing. So the in a typical coal-fired power plant, if you start doing the biomass co-firing with coal, there are challenges at each stage, like in the storage, because biomass non-torrefied pellets are hygroscopic in nature, it will absorb moisture during storage. So we need to, and apart from that, it takes the moisture, then it will undergo a decomposition, the microbiological decomposition system that will deteriorate the total fuel content and value, and it cannot be used further. So that's why storage time should be shorter, and as well as the closed storage, even that a short time we need to have a closed storage. And then handling also, as like coal, we cannot just like that handle and then break the particles. By breaking it, it will absorb more and more moisture because of the higher surface area. So that need to be avoided. And mixing with the coal also a challenge. Where to mix? And co-milling with the coal. Sometimes preferential grinding may take place because the biomass is softer in nature, although they don't grind much, but they are softer in nature. So they can keep accumulate at one portion, although you intend for a 5%, but what we see at the end of the coal mill may be at times 15%, at times 0. So that may also happen. And combustion, it seems to be all right. And fouling and slagging also is there because of the high alkali content. So for a co-milling of a biomass with the coal, torrefied pellets are much better in nature. And because it is again hydrophobic in nature, it doesn't absorb moisture, and it has a higher brittleness. It can easily grind in the while clarifying, the volatile content also significantly comes down. This will help in reducing the fire hazards. So apart from that, there are other
modifications we can do by reducing the mill inlet temperature, but that will have a consequence on increasing the flue gas temperature that will lose the efficiency of the boil. So, like I said, there are some options we just discussed here. So the options are we can mix the biomass pellets with the coal and the coal yard, like a blended imported and Indian coal blending. Similar way we can do it, and similarly raw coal bunker, and as well as the conveyor belt, and using a dedicated burner and milling system. So the each one has its own advantages and disadvantages. So if you are fixing the biomass on the in the coal yard, it's not good because it will absorb moisture, and it's during rainy season, its possibility goes up. So this is not a recommended methodology. And we can directly mix in the raw coal bunker, but it has also consequences because the mixing may not be uniform. Because you try to dump everything, or maybe it's a 8-hour storage, so I'll 5% means half an hour storage equivalent biomass fuels I'll dump into the charcoal bunker, means it will not mix properly, then all things go wrong. So that's also not. But the next methodology is that mixing the biomass pellet on the conveyor belt. So you have a biomass storage bin and then a feeder and a conveyor belt which conveys at a desired proportion as you intend, and that is equivalent to the proportion of the coal. If the coal is going at a 95 ton per hour, then the biomass can be sent at 5 ton per hour. That equates like 5% co-firing on a mass basis. So this is after a thorough analysis, we found that this is one of the good methodologies, mixing on a conveyor belt biomass pellet mixing. So this is as of now I spoke about this ball mill based systems. If it is a ball mill system, and the ball mill have an inherent thing that it has a spark in the mill. If the spark is there, then we cannot go for a higher volatile content fuels. Even in coal itself, we recommend that it should be less than 22% by volume. The coal should be. For a normal Indian coal, it will not be any issue. But whereas for biomass fuels, if you start increasing the co-firing proportion, it's going to have a mill fire hazard. So for that, we have proposed a methodology where you put a separate bowl mill. In that bowl mill, you mix the coal and biomass, torrefied biomass, in a higher proportion, say 50%. But the question of the ignition will come into picture. So for that, to avoid that, take the air at higher temperatures and then flue gas after ESP, mix it these two and then send into your mill. So thereby, in such a way that the oxygen content in the resulting gas has less than 10% by volume. So by then, as the oxygen content reduces in the mixture, the flammability temperature also goes up, so that the fire hazard can be eliminated. Yeah, some of the studies we have conducted few years ago on the biomass pellet co-firing, they were all stable flames, and because of that time what coal has is a 4,000 kcal, 4,200. So the coal what we are using is 3,400. So it's a much better than the coal. So the stability was good, and NOx also we found it's reduced. The efficiency depends on the moisture and hydrogen content in the fuel. So the conclusions are that biomass fuels are wide variety in nature. A thorough analysis is required, and during and as well as after, and as well as this fire hazard in the mill is more. So either we have to reduce the mill output temperature, or here also we can propose having a flue gas and the air mix system into a mill for carrying the pulverized fuel. And we have seen the optimal methodology for the pulverized coal ball mill based systems as well as the ball and tube mill based systems. Thank you very much.
Thank you, sir, for sharing your experience with us. Next, we have presentation on business model for R&M, held by Shashi Kumar Sarva, sir.
Very good evening to all of you. Looking into 2030, if we see the fleet of our thermal power plants, there are some very hard facts staring into us. Like 68 gigawatts of our thermal capacity would have already crossed 20 years of their useful service. Now forget 2030. As we speak and sit in this room, already some 15 gigawatts, some 40%, some capacity of 15 gigawatts would be requiring R&M interventions. Because some 40 gigawatts would have already crossed 20 years by now. So these units have suddenly become very imperative and indispensable for the Indian power sector, considering the current scenario of the requirements and the surge in the demands. So now if we consider, even if out of this 40 gigawatts of the 20 years, greater than 20 years fleet of thermal power stations, even if we consider conversion of 40% for R&M, of course, some RLA and condition assessment studies would be required. So even if 40% is taken into R&M, that would need a huge amount of some 50,000 crore rupees to be invested. Conventionally, normally the utilities would award on a competitive basis only for the equipment purchase and supply and erection awards, contracts, and that would be based on the fund availability with the utility. Now there are certain utilities which don't have the funds, so gradually they would just let go the unit and the conditions, the operating parameters would go on deteriorating with time. So considering the MOP directives, considering the current scenario of the power requirement in the country, MOP has also issued directive for not retiring these units. So now it becomes more imperative to look into options because the conventional methods have not yielded the desired results. So now we'll have to look into options and explore methods and means as to how to look for funds for these units, for the R&M of these units, as Malik Sir was saying. So this, ladies and gentlemen, welcome to the business model, which aims at achieving this very objective of funding these R&M projects, even in the condition of scarcity with the utilities. So this model has been brainstormed at our stationery Raipur NTPC department under the guidance of Sri R. Sarang Pani sir, who is CGM stationery and head of R&M. So the idea is to bring into to take into loop an investor who brings in the money for investing in the R&M project without any contribution from the utility. So the utility has no fund requirement and no requirement to fund it upfront. And in turn, the investor gets paid back in 15 years on an annuity basis. Now there is a condition: what if the investor is not having that much of patience to wait for 15 years and he does not want to get involved in the project for 15 years? So to cater to such situations, we have devised another model B, which offers an exit plan for the investor after 5 years. And since after 5 years he would have proven the R&M successfully after PG test, so he can also claim a premium on the stake sale. So from 6th year onwards, he can sell it to any other party, any other investor, or it can sell back to the utility itself, since by that time R&M would have been proven. Now here are a few model assumptions considered, normally in line with the existing state of affairs in the country. So one important thing is the cost of coal. Obviously, I have taken 4,000 rupees per MT. But if we talk of non-pithead stations, this figure would be high and the returns of this R&M would be even more. So the situation will be better. An investment considered for the R&M is 3 crore rupees per megawatt for plant and machinery, whereas 0.4 crore per megawatt we have taken for as the residual balance capital left of the ongoing enterprise earlier, and 70 crore rupees for land lease.
Now, escalation in fuel cost across 15 years has not been considered. If that is also considered, then the situation will be even better. So we have taken model assumptions on a conservative basis so that one point is driven home that it is still a win-win situation, even if we consider the most conservative of approaches. So here there are four important benchmarks that would like to focus on. One is the pre-R&M heat rate. Let us say it is 2900. In certain cases, there are for old stations we have pre-R&M normatives also. Let us say for a 210 megawatt, for a new 210 megawatt, the normative would be 2430, but for the old stations it would still be 2600. And after the R&M, if we are able to achieve 2300 kilocalorie per kilowatt hour. So these are the basic premises. Now, considering a 3.4 crore megawatt investment, which is way above, or let us say, which is a projected figure, considering the past historic investments in R&M projects. Suppose there is a capital requirement of 787 crore. It all boils down to 787 crore, out of which 70% can be funded through debt, while 30% can be funded through equity as per the CRC norms. Now, there are certain important conditions in the annuity model. It's a 15-year annuity model, so the bidder, the investor, gets paid in a span of 15 years. No funding is required from the utility. The competitive bidding is on the basis of the lowest levelized tariff for 15 years. And the bid will be rejected if the quoted rate, heat rate, is greater than the pre-R&M design rate, so as to say encourage efficiency and efficient bidding. Now, post R&M, there is a provision to protect the interest of the R&M project and the utility. There is a provision for LD for performance of shortfall in first year. Then overhauling may be supervised by the bidder. AMC will lie with the bidder to the second PG test. And now bidder's return on investment through annuity, what it will comprise of. So basically, as per CRC, you can recover only through tariff. So I have considered tariff as the only source of fund for the payback as well as the sharing of ECR gains with the utility. So the tariff fixed components would comprise of return on equity, that is 15.5% on 30% of the capital deployed. The depreciation on 90% of capital, interest on term, these are all normal as per CRC norms. And one very important thing, a 15-year irrevocable agreement for assured returns to the bidder. This would be required to protect the interests of the investor, so that if the operator is not able to operate it in an efficient way, then the investors would not suffer out of it. Then part B comes the share in ECR gain due to heat rate reduction with respect to normative values. Now, this we have kept in an increasing trajectory. In the first year, we have considered the gain in ECR, 30% of the gain in ECR to be shared with the investor, where the 70% goes to the utility. And gradually, this is increasing from 30% to 60% in the final years. So this is basically to promote instill a thought in the bidder, the investor, to have a long-term outlook of this investment, R&M investment, so that later on, if he gets more, his mindset will be of such a nature. Now, considering all these assumptions and putting it into an exhaustive Excel sheet, this is the commercial outcome that has come out. So now, to the left side, if you see, there is an arrow, pre-R&M actual, pre-R&M normative, post-R&M normative, post-R&M actual. Now, this sharing in heat rate gain can happen out of the differentials in any of these four levels. And that differential will depend upon the market dynamics. Suppose if there are lot many investors in the market, so we can go for model world conservative, wherein the share in ECR gain happens only between the differential between post R&M actual and the post R&M normative. Suppose if the investors are very few, so we can tilt the scale to the investors by taking the model 2, wherein the heat rate gain, the ECR gain will be affected from post R&M actual and pre R&M normative. So if you see into all these figures, the important thing which boils down is In total 15 years, the investor will be getting a 550 crore, which boils down to an NPV of 106 crore with an IRR of as high as 16.2%. So apart from the ROE on the equity, the bidder's share in the ECR gain would be either 415 crore as per model 2, as per model 1, it will be 173 crores. Now coming to the utility share. The utility share, number one, the gain in the loss reduction. That will be the hidden gain to the utility, which would earlier maybe would have getting funded from the state government, or let us say that inefficiency was being passed on to the customers in the form of higher tariffs. So that is one aspect. Post R&M normative and pre R&M heat rate. So that difference in the loss reduction that goes into the pocket of the utility. Second part is the gain in the ECR. So as I told you, 30% in the initial years will go to the investor, whereas 70% goes to the utility. So for the utility, ranging from 70% to 30% in the last year. This is the trajectory for the ECR gain. So if you look into that figure, it is 480 crore for model 2, whereas for model 1 it is 200 crore. Now for the part B, major things will remain the same. The only thing is that in part B, model B, the investor would have an option of exiting the investment, exiting the project after 5 years by selling his stake. First preference will be given to the utility, or he can sell the stake to other investors, interested investors also, because by that time the R&M would have proven, so they can command premium also. Now this is the commercial outcome for 5 plus 10 years model. For 5 years model, again, if you look into the broader picture, there is a huge gain for the investor also, 15.5% of IRR on equity, and for the utility also, or for the new investor also, for the remaining period, that share goes into the pockets of the new investor or the utility.
Can you please go to the conclusion?
Yes, sir, right. So the conclusion is basically that this particular model of sharing of ECR gains, the broader thing is these figures might vary from project to project, but the broader thing is that this is a win-win situation wherein an investor, if it comes with the money and deploys it for the heat rate improvement and for running the plant, sustaining the generation rather than going into a new project, then the inefficiencies, they will go out, and out of those inefficiencies will come out the money. So basically there is money hidden into these losses which needs to be extracted, and it will help the country also sustain the generation which is much required. So going ahead, the only thing is that this model being new and not practiced as of now. So this needs to be taken to the stakeholders, and policy formulations are needed from maybe REC, PFC, guidance support from CEA, because we have come across certain DPRs from the state wherein they state that we don't have any reference in the statutory documents to go ahead with this, although there are investors, but the statutory references are not there. So one very good thing which has been done recently by the CA committee, there was CA committee wherein our Sarangpani sir and Malik sir was also there in formulating the important policy document issued in 2023. So that is one milestone which has been achieved. So similarly, this is an add up to that, basically that service model. So this is all from my side. Thank you so much.
Well, thank you, sir. Now may we have our last presentation by Dr. Anil Kumar Das sir on imperatives for changes in inspection modalities and diagnostic in changing scenarios.
Good evening to all. Malik sir, Tripathi sir, all the speakers on the dais, delegates and my colleague. Actually, in this session of the R&M, I just wanted to highlight what are the importance of the diagnostics and assessment what are the different tools which are available to the utility which they can use. And as I can see that with the fluctuations and at the fag end of the day, you all are fatigued. Similarly, the components also undergo the different type of failures. So whatever the experiences we are having from the NTPC, because Netra from which I have come, they every year diagnose or analysis at least 150 to 200 failure. So I would just like to present some of the failure analysis and diagnostic that we use in our NTPC, which will help as an important inputs for any RNM. We all know that the RNM and the life extensions, what is the objective of that one? And as per the report from the CEA, the 2020, the objective of RNM is not only to increase the performance, but also it has to be all inclusive. That means in the era of the renewables, it has to also balance out or accommodate the renewables. So that is, in spite of the improvement of performance, it has also to be accommodative to the renewables which are coming in the big way. So there may be various approaches or steps which may be there to tackle the concerns with the flexible operations. Like for any successful RNA, we require that there should be a study and assessment of actual damage and the damage potential, or also we may go altogether for the new plants which may have the higher efficiency, or we may go for the design and the control modifications. Also, we may emphasize the maintenance strategy, or we may have the operational guidelines, including the chemical guidelines. But out of all the 5 that I have highlighted, I will only touch the 3 which is highlighted in the green. We all know that we may have the various regimes under the flexible load cycle. It may be the low load, or it may be the operation above the maximum continuous rating, or maybe the cold start, warm start, hot start, or it may be the spinning reserve. So as per our experience in our failure analysis lab, we have found that the pattern of the failure has changed. Well, earlier we used to get the samples. It was the base load operation. It was mostly the oxidation and the creep. Presently, we are getting the sample from the power plants which are served as the base load, as the flexible load, and the changes in the damage mechanism as there. That is, apart from the creep and other things, there are the critic failures, and also the new materials which we have opted. Many a times we are not aware that what are the precautions we should take. And in future also, apart from the flexible load operation due to the renewables, we may have also the flexible grid. So to accommodate all those things, we may have to altogether different type of data and the testing which we can do in our lab to understand what are the different changes we need to do. So in the era of the flexibles, we have found this is just the bar chart, but this is based on our analysis also, and also it's equal with whatever we have received with the PPRN. That due to the flexible regimes, there is a crevasse of the failures, and the trend is like the most of the failures are there in the water well tubes, or where the superheater tubes, reheater tubes, economizer tubes, and then comes the superheater headers and the others. If we go individually in the more detail, that what are the different components in the boilers, like the tubes, headers, and pipings. So just to have categorized the 2 parts, one is the water touched, and second the steam touched. In the water touched component in the tubes, in the water well, the most of the failures be coming in due to the corrosion fatigue, due to the deposit corrosion, then the external thermal fatigue, pitting, the sort of overheating. Apart from that, there is some erosion and also fire side corrosion. For the economizer, the concern is the acid dew point corrosion. For the steam touch tube, like the superheater and reheater tubes, the failures are coming in the dissimilar metal well. Then there are problems of short-term overheating, tube rubbing, soot blower, long-term overheating, tube well connectors or attachments, and the tube vibration induced fatigue, pitting, fire side corrosion, stress corrosion, cracking, and the flash erosion. If we come to the headers, we see that the water test headers in the economizer inlet headers, internal borehole, stub tube, header well thermal shock or the corrosion fatigue. In the water well header, there is external thermal fatigue. Then there may be some problem of the improper material or the manufacturing defects. In the pipings, which is water test, there may be problem of the thermal fatigue, thermal shock, borehole and ligament cracking. Then there will be misalignment of the support. As far as the steep thrust headers are concerned, there will be problem with the penetration well connection, which may be on account of the creep fatigue. There will be external thermal fatigue, high temperature, header boreholes and ligament cracking. And coming to the pipings, which are steam thrust, there are problems in the weld connection due to the creep, condition of the metal weld connections, then the piping thermal shock, piping drain. Then there are follow the piping misalignments. Now just to represent some of the failure samples that we are got in our NETRA lab. First one is the water well tube samples. From one of the stations, we got the 4 samples and all the 4 fell due to 4 different regions. My colleague, Mr. Praladi here, who had analyzed the sample. So we have seen that in the 210 megawatt units, the first one on the top, that was overheating due to the severe under deposit. And deposit problem is one of the severe in case of the fluctuation of the load. Second one is the due to the hydrogen damage. Also, it is on account of the deposits that we are getting, and depending on the water quality also, we are getting the hydrogen damage in some of our power plants. Third one is the short-term overheating, which is showing the typical failure mechanism. Fourth one is the violent rupture that we observed, which was on account of the manufacturing defect. Similarly, coming to the fatigue type of phenomena, we have found that in the various superheater and reheater tubes, also in the water well tubes, we got the different failures of the fatigue. Like in the superheater tube of the 500 megawatt, you can see the multiple circumferential lines. Second one is the reheater tube for 500 megawatt, which is the material was T22, where there were thermal fatigue along with the degradation. Third one was the superheater tubes, again for 500 megawatt, where the thermal fatigue crack are initiated and it was the failure was assisted with the creep. Fourth one was for the water well tubes, where there was corrosion fatigue. Coming to the overheating, there were all types of short-term, long-term overheatings, which are typical failure features that you can see it here. One more thing that we have done that apart from the whatever the failure I have shown, in our NETRA labs, we found that there were the overheating in the alternative superheater tubes. And we try to develop an online in situ techniques which can diagnose these type of failures in the field itself. And in this case, we carried out the experiment with the magnetic coercive force, eddy current-based method, advanced electromagnetics, and we found that, and also we correlated the findings with the sigma phase, which is the indicator of the degradation. And we found that these techniques showed a good correlation with the sigma phase. So in the field, we can use these techniques depending on the access and the location. We can deploy one of these methods. Then coming to the damage and failure in the piping and headers, you can see that there are cracks in the vent line in the 500 megawatt header. Sometimes we will find that even the small crack in the vent line may make the header waste. Similarly, with the flexibility, you can see the various cracks in the stub joints, ligament crackings. Also, we have experienced some of the cracks in the headers in the pipeline also. Then coming to the turbines, with the flexibility, we have found that there are the cracks apart from the steam turbine blades. First time we also noticed the crack even in the rotor disc also. So all these require the different advanced diagnostic tools, and many a times these tools are not readily available. So in our NTPC NETRA, we have developed, adapted, or also adopted some of the advanced techniques which are available globally, and we are using it increasingly. Just like the first one is the robotic device for the internal inspection of the headers. This is nowhere available anywhere, even abroad. We developed it with the CMERI, and by By now, I think we have inspected more than 400 number of headers for the different projects of the NTPC. And you can see the clarity of the internal images that we have got with this one. Second one is the MCF-based method we have developed for detection as well as the quantification of the exfoliation for the austenitic superheated austenitic essential tube. And we have also filed a patent for this method. That with this method, we have found that the magnetic coercivity shows a good correlation with the quantum of the exfoliation. And based on this trend, we can take a decision that whether we should cut the bends or clean or whatever action we are to take. Similarly, we have increasingly started using of the phased array UT earlier since 2011 when we started in Netra for the inspection of only turbine blades. Nowadays, we have also started with the boiler tubes. And NTPC is using it extensively. Third one is the eddy current array that we are shortly going to use for the turbine blade root area and also for the steam turbine disk. So that whatever the fatigue cracks which are in the initial stage, we can hit it with this one. Fourth one is just the frequency scanning eddy current testing, which is the only tool available with NTPC, even it's not available with the GR&D also, and even the aviation department. With this, we can find out what is the relative level of degradation of the coating so that we can have the informed decision whether we should go for refurbishment or not. And also, just one line I want to see that when we are going for the higher efficiency, like we are using the Super 304H material, though it has the higher oxidation and the creep property, but we should be very much careful while handling the material. And in NTPC, we have found that the various failures in this were on account of the stress corrosion cracking, which came because the tubes were exposed to the corrode environment, maybe during the fabrication, storage, or erection. So that is one caution one should take when they are going to use for the new material. So just to conclude that R&M has to be all-inclusive and should support, balance the use of renewables. There are different approaches to the R&M. And the utility must be aware of the gravitating effect of the cycling loading vis-a-vis failures of different power plant components like the boiler, turbines, and auxiliaries. And to have coverage of the major critical areas for inspection, there is need to deploy the advanced NDE tools along with the conventional NDE tools. And many of these NDE tools are not readily available for specific applications and need to be customized and developed. NTPC has adopted and developed various diagnostic assessment tools for increasing the coverage of the inspection and increasing the reliability. And various advanced NDE tools just discussed like abstract, PUT, ECE, electromagnetics, even for the hydrogen damage, along with the robotics, they may be deployed to detect the defects reliably in many regions effective as flexible operations. And even the use of the new materials, we should be very much cautious and should be aware of the different damage mechanisms so that we can use it reliably. Thank you.
Well, thank you, sir, for your valuable insight in the research areas, what you have done so far and what you are involved into. Now, this session is open for any interactions. If anyone have any queries, they can ask our dignitaries on the dais. Any questions? Okay. We shall proceed to, yeah, it seems so, sir.
Will not be operating on a fixed grade of code because this basket mines concept and this concept is changing. So whenever there is a wide variation of coal quantity, including PM and ash or whatever, then how you are going to take care your new burner system so that in the flexible operation of 40%, we are able to get the desired result. Because nowadays, when we are planning R&M, it is should be a business model. Why I will do R&M? It are not giving me any comfort either in terms of reliability, cost, as well as increase in output and setting our ESG. So how you are taking care of this wide variety of things? Because normal now it is not units are not operating mostly on the design code. Design code is only critical for calculation. The practical aspect is we are operating in the range of 1,000 kilocalories. So that was my question, because you started a good topic. Please.
So it was a good question. Actually, this the need for the new enriched gold nodes burner, it came from customers only, because a lot of contracts what we have built is starting with a higher caloric value, maybe even 4,500 or even 5,000. But later, when it comes to the practical one, it goes to even 2,800 also. So when we design that, it will be a good code. And during the initial stage of the contract, they'll be getting it. Later, once they get the degraded code or the ash or the ground flow, that will create problems. So the new burner, what we have developed is, we have tested it for two, as in the power plant also I've shown. It's tested for the worst code, like low VM code, 16% volatile metal. So that is what the worst we have seen. And it is checked with the what normally we get, around 21% of volatile metal. So with these two conditions, these two boundary conditions, we have tested that. And even though we have tested it for 21, we are confident enough that even if it's less than 21, maybe of, let's say, example 18 or 19 also, it can work. But it has to be tested. We cannot say that it will work for this percentage of yield. Thing is, so many other factors are there in this. For example, the pulverizer should be there. It should give the required fineness. And your whole pipes all should be balanced. Your scanner should be intact, as well as you have the correct position. Because in this CFD analysis, we came to know that even the scanner position in the wind box has to be properly made. That was a new finding in this burners. Same thing was tested in Tuticorin also. And they were very comfortable. The operators who were doing this, they were very comfortable in doing up to 40% also they were. Because there was a problem in the TG, they could not go still further. But they were, we were confident up to 30%. So just we asked them also, whenever you are going to shut down the system, give us an opportunity, you want to test it. Because the new design what we have developed, with the lowest VM and the highest ash, we have checked it. The safety analysis is showing a good result with this configuration. And this is not a new technology, but few more things we have added into the coal burner tip, which is enhancing the concentration of the rich mixture in front of the coal burner tip. And it is always recirculating, so that once the vortex is formed, the recirculation of gases is making even the worst coal of the ash is burning at a right tip, and scanner also is holding it. So with this, whatever the ash or the coal you are giving it, but it has to be field tested. We cannot tell everything on theory or paper. It has to be field tested.
Okay, thank you. I think we have got another session after that.
No, sir. They have shifted to NALANDA. So that restriction is not there. Right. Okay. So I will just, sir, with your permission, take just an extension of your question, sir. Person from, gentleman from VHL Trichy. How do you compare your burners with the plasma burners? Because plasma out India it is not there, but in outside countries like China and even South Africa, Zimbabwe, we have found that. How that did it compare with that? There also oil consumption is less.
So sorry to say that I have not done or doing analysis but we are like, I think one more department is there which is dealing with this. They are in the developing stages. So I don't have much knowledge on this.
Yes, sir. At this moment, I'd like to request Tripathi sir to enlighten us with his thought on this session and guide us the way forward in R&M challenges.
Thank you. I think regarding the need of the R&M, I think context of this session was set with the need. So there is no further need to elaborate. But you know, the requirement changes with it changing so it is so dynamic. In 2008-9, we were I think R&M history from 90s we have started R&M. Then R&M was so-called an activity which will taking backseat to the power plant operators. Thereafter, some norm scheme, there are some incentive scheme from CRC regulation. We started doing something part manner. And thereafter, uh, due to renewable addition, a concept has come. Things are, if not improving or not up to the mark, then we have to discard. So retirement is planned. Now, when we are short of, I was in the meeting and when it was decided, the 10,000 megawatt is supposed to retire, but suddenly we got a huge demand post-COVID, and the entire scenario got changed. So at present, the R&M is the biggest challenge before this industry. In order to cater the demand during the evening peak or somehow taking the total energy security of the country make further. And we are seeing that next at least 10 to 20 years, nobody is asking you to retire as per my projection and the analysis of the sector. So it is not going, nobody is saying to retire. So the R&M, of course, the many challenges we have already asked, but the real challenge is the cost economics. The, till now, NTPC is operating plants with the support from the in the regulatory mechanism. We are getting something reimbursed. But you think as a private whose plant will be older and he wanted the R&M, how will it operate? So, of course, there was one topic, the business model was saying. That was very good. I think this model was tried for some components like cooling towers, that whatever performance it is coming, we will share it. But as a total R&M, if it is going to be shared, it will be a very good option. And certainly more and more work is required to be carried out. And we must have a very robust model that any generator wants to get some improvement, at least we will get fund very easily. Because till now we were thinking R&M activity as a technical activity. So now it has become techno-commercial. Sometimes some people came with bags in hand. Okay, this component requires some coating. We are going to do some R&M. Now days are gone. We must have a concrete objective of any R&M, and this objective must be cost effective, and it must be evaluated on the technical and the commercial aspects of it. So I think this session has, I think 3 or 5 presentations all have touched some of the aspects regarding the commercial aspects, some technical issues. In turbine, of course, he has gathered many various options and what are the scopes that we can do with more and more scope based upon the requirement. Suppose as an owner, I want this much of heat rate. So the conventional BOQ is not going to work. So tailor-made solution depends upon the site is the need of the hour. Now, my friend, all from energy sector, entire world, or in fact in India, is looking forward and looking towards us, how we are going to maintain our demand. Now, ministry as well as the PMO is constantly watching the era of March to April 2024, where we are expecting another 10% jump over the peak. So the entire generation planning, as well as whatever the capacity addition that we are going to take care is very, very important. Then R&M is very, very important solution for us, where in a very short span of time, we can enhance the capacity and as well as the efficiency. Now with the more RE, flexibility comes as a biggest challenge for. And when flexibility, already we have talked about the
reliability and the life of the components which has been designed earlier for certain period of time. So these are the challenges before engineering, that is technical challenge, or to the commercial to pull the R&M in a basket that it is commercially viable, for the policymaker to give a good solution so that whatever, because every generator is doing business. So it should be a sustained business for any generator. So I think the R&M philosophy is to be designed for a private operator, you see. Not a single private operator has come towards the R&M until unless he got a complete picture कि मैं ₹1 लगा रहा हूं तो मेरे को ₹1.5 मिलना चाहिए. So that is the need of the hour. And I hope such type of session will enhance the total grasp of the subject, and in the think tank of this R&M field, people will start thinking. So thank you very much. And I'm very grateful to the organizer who has allowed me to hear these 5 sessions, lot of learning. Thank you very much. Thank you.
Well, thank you, sir, for your kind words and your vision about R&M challenges that this country is about to face now. With this, we came to the end of the session, but before we leave, there is a small token of appreciation for all our dignitaries on the dais. Can we have the mementos, please? I request Vikas Chand Malik, sir, to present a mementos to SN Tripathi, sir. May I now request Vikas Chand Malik, sir, to present a memento to Anil Kumar Das, sir. I would again request Malik, sir, to present a memento to Sekhar Thakur, sir, from GE. I would again request Malik, sir, to present a memento to Sivaji, sir, from BHL. I would again request Malik, sir, to present the memento to Pritam Kumar, sir, who has came from BHL Trichy. May I now request Sri SN Tripathi, sir, to present a memento to Vikas Malik, sir. Oh. May I now request Tripathi, sir, to present a memento to Sashi Kumar Sharma, sir. I would like to request again Sri SN Tripathi, sir, to present a memento to our session organizer, Sri Rajiv Jain, sir. Thank you, sir. And I would request all the dignitaries on the dais to please be together for a group photograph before we disperse and end this session. It's a moment of great learning for NTPC, with so many distinguished, experienced leaders from their respective areas sharing their knowledge amongst us. Thank you, sir. Thank you for your valuable speeches, valuable inputs regarding the R&M challenges, perspective, and way forward. With this, I would like to close this session. Thank you, sir, once again.